about getting this working. Come on. Come on. Stream settings. Let's grab the share button. I'm just going to mute myself. Let me just unmute myself. Close a few things. So I have got several hundred tabs open. Okay, cool. I'm just going to share the link to a few places. So Riverway. Okay. Okay. I'm just going to start by setting up the project because that's just generally good practice. So let's go down to projects. Yeah. Let's keep the scripts on because I might have to write something. Let's keep. Don't tend to use Alembic or HDAs, so let's keep it like that for now. And then hit save. And let's just call this dusting effect. Okay, so it's been a while since I've actually streamed something. So let's hopefully, I hope it doesn't go off badly. But so we're creating the effect. We grab a link to it. Similar, I can't really share that. I'm going to recreate something similar to this, where it just dusts away. I believe I do have a video of the dusting as well. So let's go to where Peter's there. Just spoilers if nobody's seen it either. So you've got this growth-like effect that's coming on, and it's kind of fracturing and doing multiple fractures inside itself. So there's a few ways we can recreate that, which is we can either do it all in SOPs, or if we want to get a bit more advanced, we can start doing adding dynamics to it. So I'm going to try and do the majority of it in just the SOP land for now. And I've just got this notepad with just something because I keep a bit of Vex code because I keep forgetting that particular one. But I want to talk about growth to start out with and how we get like a growth effect coming along. So, and I don't tend to name my nodes while I'm doing tests either. So, but we'll start out now. Test. So I'm just going to use the grid for this, and I'm just going to push the subdivisions quite high so that we're getting all these points to work with. And I could end up just using a scatter, but I find this a little bit easier. And let's say we have a point in here and I want it to grow outwards as the time goes on. So I'm going to do it in both VOPS and VEX. VEX is going to be a little bit faster. So what we're going to do is, well, we need a point where we want the growth to start off with. And you can do it several ways. The way I'm just going to do it is just going to use an add node. And I'm just going to go template this, turn on points, and I'm just going to say add a point. So I've got a point bang in the middle. I'm just going to move it down to the side down here because I don't want it to be in the middle because there's a caveat I want to showcase with using this technique. So I'm going to start the growth from that point there. And the way we can do that is if I go down to a point VOP, I'm going to put the grid into the first input, the add point into the second input. Let's dive in. I'm going to lay down a constant variable and I'm just going to turn it to integer. I'm just going to keep this at 0. I don't want this to change at all because sometimes the geometry, this thing here, can actually override what I'm about to do. So all I want to do is just want to grab a import point attribute here, and I'm going to say point number is just that one. I'm going to say the second input here, and I just want to get the attribute p. And this is a shorthand way of doing it with just 1 point. I'm going to showcase how to do it with 2 points, which is a little bit different. But what I want to do is I want to get the a gradient going from point A to point B, about depending on how far this is from this second input point here. So we can do that is we can just say distance between these two. So this, and if I plug it into the CD, we now get like this little distance attribute here. We can add in a ramp, and if we dive back up, we can make it a little bit scaled like this. If I want the range to be further, I would use a fit range here, and I would just make this higher. This only works if we've only got 1 point incoming. What happens if we've got 2, which we probably will have in the end? So I'm going to add a second point, and I'm just going to say -3.2 and -3.4. So there's 2 points basically polar opposite of each other. And if we look at this one, we're going to just be grabbing the first point here, which isn't what we want. We want both points. So what we want to do is we want to iterate over the points, and the way we can do that is I'm going to delete this for now. I'm going to delete the fit range as well. The way we can do that is we can use something called a point cloud. And the point cloud basically takes a radius, so I'm going to use something called a point cloud open. And there's two ones that we mainly use, which is a point cloud find and a point cloud open. The differences between these two is what we get out of it. So out here we get an integer value, and out here we get an integer array value. And if you don't know anything about code, or anything about, well, basically anything about code, let's just take a look at the chat, make sure no one's asking questions. Glad you can hear. So you've got the float value, which is a value that has a decimal point to it. So let's say 0.1, 1.0, sorry. An integer value cannot have a decimal point. So that's what an integer is. And in program, we've got something called floats, doubles, integers, integers, which basically means those different things are more akin to very low level binary, how much memory it's taking up and stuff like that. So all we need to know about is we've got the float and the integer. We've got the vector, which is free floating point values denoted with a curly brackets. So let's say 1.0, 0.0, and 3.0. So that means that the x position is going to be 1, the y position is going to be 0, and the z position is going to be 3. I think there's a few more. So you've got the mate. I'm not going to go into all the variables we have in Houdini because there's a lot. But the one that's coming out of here is going to be the integer value, and the one that's coming out of this PC find is going to be similar to a vector. But imagine instead of holding three values here, denoted split up with a comma, have it more so that you have an int a. So let's say the first point is going to be 0.1, 0.0, 3.0. Actually, no, these are integers. So let's say we have an array of the point numbers. So we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8. And I've mucked up the commas there. And you'll notice that instead of the curly brackets, I've put in square brackets. That's how we showcase the array values inside of basically anything. And what this means is it's going to hold all those integer and all those point numbers. So when we do a point cloud find, we are basically taking a positional value that we're going to give it. In this case, let's just say it's going to be at position 0 on all axes. And it's going to say, what is the radius, which was that fit range that we had previously. So it's going to have, it's like a clamping of a distance. And it's going to give us a list of all the point numbers, of all the points that are within that range. That we can do a lot with that, but not so much in a point VOP. It's better suited to Vex, because what we do then is we have to do something called a for loop. And that's not something I'm very happy with inside of ops. It's very clunky. So we're just going to leave it at the Vex level for now. So we don't need the point cloud find. The good part about the point cloud find is that we can use grouping. So that's where, if you wanted to have groups in there, that's where you'd use it. The point cloud open gives us something else. It gives us an integer value, which points to the current point that you are dealing with. And it's going to deal with all of them. So imagine it's taking, so if we had if we did a point cloud and we grabbed 4 points, what that would do is it will then take those 4 points, add them to, so if we wanted to get the positional value from this, it will take the positional value of every single of those 4 points, add them all together, and then divide by 4. So we're getting the average of that. This is what the point cloud open is going to be doing. And the way we iterate through what attribute we want from the point cloud is we use a point cloud filter. So let's say the current position that we are querying it with, which is going to be our current position here, so P. The file is going to be the second input, and we can have in here we've got a search radius and we've got a number of points. The cone angle isn't something we need to go into. That's more suited towards dot products and some more mathematical stuff. It's not needed here. You've also got the N normal channel, which is also not needed. So I'm just going to middle click and promote these two. And then what I'm going to do is I'm just going to plug the handle into the PC filter. And we're already getting the positional value. If I now plug this into the distance, we're going to see we have that there. Like that. But we also have a distance difference here. So what we're going to do is just going to increase that to about 2. And because we are going from 0 to 1, that is all we need. Now, what I tend to do with this radius is I bring it out a little bit, and then I actually do a fit range between this and the radius there. So that way the radius is always going to be the range there. You're going to notice that the middle point is also going on as well. That's a side effect of this point cloud open technique, because it's taking in the distance variable between nothing and itself. So what I normally tend to do is I do a compare here, and I'm going to compare the current position with another one. So I'm going to say constant, and I'm just going to say this is a vector, and I'm going to keep it 0. And I'm going to say if it does not equal this, then do all these. So I can use either a switch or I can use an if statement. I'm going to try and use an if block, an if statement, I mean. So this is the if block. And the first input is going to be the condition. And this is going to say, it's the Boolean operation. Is it 0 or 1? Is it true or false? And then what I'm going to do is I'm going to plug in the position here. Like that. And we can see this is kind of working now already, even without doing that, which is kind of annoying how it does this. In VEX code, I normally can't do this. So what I normally do here is then I take this, like that, and I'm just going to push this out into here. So I'm encapsulating this entire block inside this if statement. That means we also have to have this in the if statement a little bit, so I'm just going to move it up a little bit. Or alternatively, I can push these into the next input here. And then I can say, yep, we're going to be grabbing that there. And honestly, I can just switch these around, and they don't be needed there. But now, it's still doing that, which is really annoying. Okay, so it normally works better in Vex, so let's just delete this, cut this here, and cut that. So now we've got that working, which is the growth that we want. And we want to basically say, hey, grow this over time. And we're going to see that it's kind of fading out. Not really what we wanted to. So I believe what we can do is we can say max between this and the current position. So this is going to be useful when we actually go into the growth solver, but not right now. So it's basically, it's adding it together and it's multiplying it out, which isn't really what we want. Oops. So if I go here, it's still going to kill itself. So what we want to do is we want to take this into a SOP solver to make it grow over time. There's one more point I want to add, which I'm just going to smooth this out a little bit. It's not smoothing out, is it? Which is rather annoying. Why is it not smoothing out? Okay, I'm just going to do this in Vex instead. So I'm going to go. That was the way how you do it in VOPs, by the way. So I'm just going to do it in Vex. So I'm going to say int PC equals PC open 1 for the second input. We're going to be using the positional channel. We're going to get the channel, the actual position. We're going to get the radius, and we're going to get the points. Okay, now we're going to get the positional, which is we're going to get the attribute of position. So I'm going to say PC filter, which is the PC. So we're getting the integer PC, and we're going to say P. Then what we can do is we can say, instead of distance, we can say length. The way we do length is we do 1 minus the other, and then we just put that into a length calculation, which calculates the length of that vector. So I'm going to say float dist is going to be length, and it's not len, it's length, because len is used for arrays. I'm going to say the length of current position minus the position. Then I'm just going to quickly add that into my CD here, and nothing's going to happen. So I need to increase the radius a little bit. And we can see that it's having the same effect there. I'm actually going to swap these around. Didn't do anything. Brilliant. And what I'm going to do here is, well, we could just do distance. So let's say distance between at P and pos, and we're going to get the exact same result. So then I'm going to put down an if statement at P does not equal so, then at CD equals dist. That's very weird why it's doing that. It's kind of taking the first input, which, or is it at point? No. There was a way I did this last time, and I can't remember what it was. So for now, we're just going to deal with that. It's a byproduct. What I'm going to do is I'm going to just get rid of that for now. I'm going to say float R. It's going to be channel ramp. I have great naming. I'm going to say ramp between the distance. Like so. And now we have this ramping effect here. So I'm just going to go back so we can see it. And we can see it's kind of doing this waving, this sine wave effect. So I want to fit this between 0 and 1. So I'm going to say fit between 0, channel float radius, 0 and 1. So now we've got that. What I want to do is, so I want to try and give this a bit of noise, so it's not such a uniform sphere. And the way we can do that is we can add, so there's an old technique inside of when we're cutting up geometry, is to mess up the geometry, add a rest position first, mess the geometry up, apply the fracture or the Voronoi fracture, and then once the Voronoi fracture has happened, we put the rest position back. We can just do this directly in Vex, in Vox. So what I'm going to do is I'm going to use the sparse convolution noise. And the way I do that, the way we do that is we say vector. I'm going to say SN for sparse noise. I'm going to say vector because I want to make sure this is being cast as a vector. Otherwise, it's going to be cast as a float. I'm going to say S noise. Then I'm also going to times it by a channel float of amplitude. So this is how we do it. The amplitude of the noise. We plug in the positional value. We then do the number of turbulence that we can get. We then do the roughness and then the attenuation. Nothing's going to happen for now. But if I add this to my distance, then we're going to find that it's actually noising up this. Now, let's say we want to give it like an offset, or if we wanted to have it more, basically we wanted to just give it more frequency. So the way we do that is we multiply the position for frequency, and we take away with the offset. And I'm actually going to put the offset up here because I'm going to mess with it later. And I can either say channel float offset, or I can just actually add a value. So I'm just going to say off here. And then I'm just going to bring the frequency up a little bit. So I'm just going to quickly investigate as to why the PC find is actually giving me like a distance there. Because there was ways that I could get around it, but I can't remember exactly how. if anybody knows, can you please tell me? That would be great, because I don't want this going on too long. I have a feeling that the reason we're doing this is because we're using a PC Open, not using a PC Find. And the PC Open, if it can't find a point near it, then it's not taking the positional value into account. So we need to figure out how many points, how much there is in here. So let's go and just make one. So I'm going to say integer a equals PC. And that's just a very hacky way of doing it. So some of these have got 0. They've all got 0. Okay, that doesn't help us in the slightest. What I want to do is, should be a way of getting the length. PC len. Let's take a look. Point number found of PC. So some of them aren't finding it, some of them are. So let's try that. So I'm going to say if this does not equal nothing, then do that. Yep, that was it. So the way we would do that in PC, actually I won't show PC Find just yet because that is a bit more advanced. That's how we do the PC Open effect. And I can just, honestly, if I wanted to, I could just say scatter on here instead. Instead of it's got like 1,000 points. So I'm just going to say 5. We're going to see that happen as well, which is a little weird. So let's figure out how we can get around that. Between this, actually no, not clamp, let's say max at CD. And that doesn't really help us. So let's bring this up the other way. I'm going to actually color it. A little complex, okay. Fair enough. I will go back to VOPs instead then. I'm just going to make this all black. Let's see if that helps in any way. So the maxing isn't helping us here. It will later on when we don't have this many points. Okay, so I'm just going to dive back into doing it in VOPs instead. Cool. Let's go to point VOP, and I'm just going to recreate this. I'm just going to copy it and paste it into my notepad so I know what I'm doing. And I'm going to, I'm not going to use that color. I'm just going to use this scatter node here, and I want to get the exact same result as it did here. Okay, so we had a PC open, we had a PC number here, and we had a PC filter. Okay, so as before, we're going to plug in the second input into my PC open here. We're going to plug in the positional value into here, and we're going to promote the radius up at least. I'm going to bring this back out as well. And then what I want to do is I'm going to say PC num find here, and I'm going to do an if statement. So I'm going to put down an if block, and I'm going to do a so boolean. What was the one? Was it a switch? Was it a compare? Oh, it was a compare. So I'm going to say compare this if it is not equal to 0, then do everything else inside here. So my first input is going to be my positional value here. My second input is going to be let's just do the PC filter here and plug that into the second one. And I can actually give these names, but I don't really want to just yet. So actually I will. So let's just call this one in P and in PC, but in point cloud. And now what I want to do is I want to say distance between this and this one. I'll plug that into the CD now. We're going to get that. I'm also going to plug in this radius to here. Let's call it radius. I'm just going to keep these all into this in block so it looks a bit neater. And I'm going to say fit range between the source min of 0, source max of the ramp here, and I'm going to keep this 0 and 1. Then I'm going to say put a ramp down. I can put a ramp down either here or in here. Let's put it down here, like so. And we're getting almost the same, so I'm going to put it to be about 2.8 the same as well. So we're almost getting the same result. What I'm going to do is I'm going to change it from linear to, I'm going to change it from RGB to a spline ramp. And then I'm just going to push it up. Let's try it the other way. No, this way was good. Yeah. Not too sure why it's going the opposite direction. Because I'd like it to be everything to be black, white, and this one to be black here, but it's doing something else, which is a little weird. But for now, or I can put the ramp in here. No, doesn't change it. Okay. So I'm going to put the ramp there, and so that means that, come on, I want to have this be the same, but it's not being the same, which is really annoying. So PC filter P, it's taking the second input. I'm just checking over it all again. Yep, okay. So let's swap these around to 1 and 0. And I'm just going to bring this down a little bit. Try and match that one. So that's what we're getting over here, roughly. It's just not the way I wanted it to be, because this is blacking out the rest of it. So what I can do is instead is I can just say add to the current constant, which is just going to be 1. Or I can say max, which is going to get the maximum between these two. So I can say constant. Which is not going to help, so let's just try plugging it into the CD. Nope, that's not going to help either. Let's try the minimum then. That's not a good idea to do that, by the way, to have it. Okay. No, still not helping. Okay. I don't know why it's not doing that. So great, one hit already. So, okay, I'm just going to check over what I've got here. So, in PC, it's going right. The number is, no, that's not right. That's fine. The point number, the distance, channel ramp between that, the distance and radius. Yep. And if it does not equal 0, then just do R. Which is kind of annoying why it's not working. So we can either say not equal or greater than. So this one's getting multiple points. So let's turn down the amount of points it's going to get. Let's just say it's going to get maybe 1. And you can see it's starting to get something like a Voronoi effect going on, which is kind of interesting because this is the mathematics about how Voronoi uses it. Can we use this for our source spread node instead of that? I don't know. Haven't totally touched into it. Let's take a look at that. Can I visualize the diffusion? Let's take a look inside by interesting. How come I cannot actually dive inside it? It's already opened. Okay. So it's already got a solver. It's doing all this. It's doing an Ashford wrangle, which to remap. It's giving us some noise. I have to create a temperature attribute, right? That makes sense. Constant initiate fuel. I'm just trying to see how it's doing it. Come on. Side. And this is probably the workhorse. So we've got a diffusion, constant add. Just adding, yes, that's what we want. Total burn. Then it's doing a minimum between those two. It's doing a reaction. And that's just the scaling down, I believe. So we're going to do something very similar to this. Anyway, this is just showing how we're going to spread it. The thing I don't like is that it's spreading it a little weirdly. So what I'm going to do is arc this point up, which is what I tend to do with Vex, honestly, because I don't have to deal with these if blocks and stuff. I am going to grab a turbulent noise, just to finish off this. So I'm going to add it to the positional noise, the position one here. Make sure that this is a 3D noise, and we're using this positional one here anyway. And now we're getting like this frequency working here. The only problem with that is that it's not quite working. Looks like, oh, okay, wait a second. So there is another way we can do this. Instead of adding it here, I'm going to go back into this one here. Instead of adding the noise here, I can actually add the noise here. So I'm going to bring this back up. Take this offset up because we need the offset here, and I can actually add that to there. And now we're going to get a bit more noisy stuff there, except for here. So we're going to get a distance between this and this. So we probably would need to add the same one to that as well. Okay, I'm just going to keep this because the Vex is easy. I'm sorry. It is a bit easier to understand why some things don't work than in the box. So I'm going to get rid of that. This. I'm going to keep this to about 2. And what I want to do is I just want to invert these colors. So I'm just going to do a channel. I'm just going to do a ramp. color. Sorry, yeah, I'm going to do channel wrap between you, and I'm just going to switch these around so that this is white and this is black. Cool. I will give you the hip file if you need it. So if anyone asks, I'll just give the hip file. I hit save because Houdini loves to crash on me. So what we want to do, so this is doing it this way. The other one that you wanted to, so this isn't quite growing yet, so we need to just add a growing technique to it. So what I'm going to do is I want to do this basically, and what I'm going to do is I'm going to copy this. I'm going to make a subsolver. It's just called solver nowadays, I suppose. And we're going to dive in. I'm going to bring this down a little bit smaller to be about 1-ish. I'm also going to put the amplitude down just a little bit. And I'm also going to turn this frequency of the Y right off, because sometimes interesting. Normally if you turn the Y off, it won't sync through the floor, but it's currently trying to sync through the floor a bit. So that's the offset. Let's just bring this up a little bit, and maybe just a little bit bigger. Just dive inside the solver, and what I'm going to do is, instead of using grid, I'm just going to scatter down points, and I'm just going to scatter hundreds of points. The reason it's taking so long is because I've got relaxed iterations on. If I didn't have that on, it wouldn't take as long to calculate. Okay, so this previous frame, what I'm going to do is I'm just going to blast. I'm going to say at cd.x is greater than 0.001. Leave. Just going to say points. Actually, I want the other way around. So now we just got these points that are white. I could just say, hey, are these white or not? But I don't want to. And then we're going to, how can we set the point what we want to grow? If you wanted to grow from a particular point, what you could do is you could, so as I've got this add node here as well. So I can say they're going to grow from these 2 points, or I can do like a selection inside here, or I can do a grouping using a sphere. So I can just say group. Where's my group? There it is. I can say group. Let's just say let's grab a sphere, like so. I don't need that. I need to be polygon. And I need to say keep inbound regions by pounding objects. And I need to change this from the primitives to points. So I can just say group start. And then what I can do is I can just noise this up using like a mountain or an actual noise. And then from this group I can just color it, and we can keep going. We don't. So this is showcasing how we do it at the start. So I'm just going to showcase how to do it from here, then, so that you're all aware of how to do it. So I'm going to say group. I want you to group. So I'm going to say an easy way of doing this is, if it's in a group of that group start, just give it that constant number. But beforehand, let's make everything black. So now this group's going to be there. I'm just going to give this a bit more frequency. I'm going to scale it down, and I'm just going to move it about here. Okay, so I can make it start from here, basically. Inside the solver, so did I copy that? I did not. Inside the solver, I'm going to copy that. The first input's going to be there. The second input's going to be there. And the previous frame, we're going to see that nothing's there, which is kind of annoying. So let's reset that frame. reset this frame, reset it again, and we can see we're getting something there. Now this isn't exactly what we want. What we want to do is we want to have it grow over time. So let's adjust this. Better yet, let's get rid of this and let's do it in blocks. And we're just going to ignore the initial middle child that we get there. I'm also going to lock this so that I don't have to keep jumping out. Who's messaging me? Okay. Inside the point block, I'm going to say PC open. File is second points. I don't need, because I can select the, I don't need the group now, so I'm just going to go group delete. And I'm just going to say all of them. So PC filter, oops, that's all right. PC filter. And I want to get the positional value, whatever that is. I'm going to plug it into the CD, which isn't what we want. Let's say P here. I'm going to say the distance between those two. Like so. I'm going to do a fit range between those two. And we'll see we're getting that again. So I'm going to do the radius, promote the radius up. I'm going to say fit range plus that. So it's a little bit smaller. And I'm just going to make sure that that is actually starting at 0 and this one's starting at 1. So I want the distance to be inverted. Like so. And it is going to grow a little bit over time, as you can see here. So then I'm just going to quickly add in, but what we also want to do is we want to add, or actually we're going to say max. So instead of adding, we can just say max. Plug that one in here, going to plug this into here, this CD. Actually, this is max for the floats, so let's go max for the component. That's not right. Okay, so that's getting us the maximum of those two, so I'm just going to say max instead. Max of the float component, because these are technically floats, so I'm going to say CD. This is bringing us out a float value, so I'm just going to say CD like that. Go back in time. And so now that means that if it's already got one there, it's just going to keep on adding. Now the problem here is that if we go into my geometry spreadsheet, we should be technically getting more than one. Not, which is nice, so that's good to see. So right now I'm also going to add in that stupid numFound feature, so I'm going to say PC numFound, plug that in here. I'm going to do an if block. The headaches come back. I'm going to plug in the positional value here, so I'm going to say yes if it's that one, then plug this out here, else plug that into there. Interesting. Alright, so that's if num begin. Technically it should be doing like a 0 to 1 already because it's working that way. So I'm saying compare if it is greater than 0. I need to have this be plugged into here instead, and then and then this maximum attribute. For some reason it's bringing in the P instead of the what we want. So what we're seeing here is we're seeing the positional variable. So if I go CD and I plug that right into the positional variable, we're going to see that as a positional variable. It's not what we want, so let's just go back out, see if that had anything to do with it. Nope. So we're getting this channel and a ramp. I'm a little unsure as to why it actually is giving me that the positional value because as a vector there, because it shouldn't be. However, if this is not if the geometry we're looking at isn't at 0, this wouldn't be happening. So if you don't have the geometry at 0, then it won't happen. Okay, there we go. That's a little weird, but I have a feeling that the if block is a little bit broken and it's taking in this positional value already here. So PC filter and this variable here. So I'm just going to name these. So output name is P. This one is PC. This one is CD. So that I know what these are. So it's a little weird why it's taking. Oh, now it's not. Brilliant. That's why I don't exactly enjoy Vex that much. But okay, so now that's a growing effect inside of here. We can make this faster or smaller. The way we do that is we just adjust this radius. I'm just going to reset the simulation. And we can see it's getting growing a bit faster. If you want to add noise, there's a few ways you can do it. A tutorial I watched recently showcased using the max method by doing multiplying this with a noise. So the way they do that is you go turbulent noise, or let's just do anti-alias noise instead. I'm going to set that to the position, and they would multiply that like this, which wasn't, in my opinion, a great way of doing it, because then we still get this fringing a little bit around here, which wasn't what I'd like to see. So another method I'm going to choose, and we're getting that stupid thing again, where it's taking in the positional. Let's try that. Come on. Stop taking the position. It really is a horrible feature. It does this. So let's turn off that multiply. I think the reason it was doing that is because it's taking the position and multiplying that. But what I'm going to do is inside over here, I'm going to add either noise to this one, or I can add noise to this one. And I'm just going to add noise to this one here. So I'm going to say turbulent noise. I'm going to say add to this positional. So P. I'm going to say 3D noise. Let's make it a sparse convolution because that's a 3D noise. And I'm going to promote these values up. Brilliant. It's not working. I sure do love it when it doesn't work. Don't you guys? So the reason it's not working is because it's taking the distance between that, and this technically needs to fluctuate a little bit. So, and it's still giving us like this rounded edge. So let's get rid of this and instead add it here. So position is going here, from here. This position from here to here. I'm adding that to this here. So we're getting a little bit of a noised up variation there, but it's still not quite working. We're still getting a variation thing. So what we can do is, oops, I accidentally went over the type. What we can do here is we can say, we can add an offset. So I'm going to promote the offset up at this, and I'm going to say add this one. I'm going to add time, or I can add the frame, honestly. And it should technically be adding to it, but it's not. So instead of frame, let's go time, because time will be a bit slower. And we're seeing that it's moving over around each other, and it's not adding, it's not saving that, which is a little weird because the solver tends to save it. So let's dive back up, and let's figure out where we went wrong. See, open radius goes to there, ramp goes to there. This being stupid here. Not found. Adding it onto this here. So okay, let's use the Vex one as well. And let's recreate what we've done in here. So actually, let's just delete this entire thing. Let's recreate what we've got. So inside here, I'll do it step by step so that we can see. And I'll actually make this one nice and big so we can see what we're doing. Inside the VOP network, we are initially, let's just take this part out of the equation. We are making a point cloud open. We're doing a point number found, and we're doing a compare. What I'm going to do instead is I'm going to use the PC find. The PC find, again, will work the exact same way. So I'm going to say int PC. Instead of just writing it like that, I'm going to add 2 square brackets at the end. I'm going to say PC find. I say 1 p at p channel float radius, and I'm just going to keep it at 10 points. Okay, so that's working. And now to go over each of these points, I can either use a PC iterate, which will give me it's like an iteration. It'll go over each point that I want, but it's not really an ideal solution for people, because it can be a bit harder to realize what it's doing. So what I tend to do is I use something called a for loop. So I'm going to say for, add curly brackets there, and the for, I'm actually going to open this up again so that we can see when it errors. And the for loop takes a few variables inside here. So the for loop takes, we say integer I. I tend to do a double I, and that's just coming from a programming practice, equals 0. So we are declaring a variable called I, and we're starting it out at 0. Then I'm going to put a semicolon in. I'm going to say I is less than the len, which is the length or the amount of points in this array of PC. And I no longer need to put the square brackets there. Another semicolon, and then I'm going to say I++. And what this is doing is I'm declaring a integer variable variable here, and this variable, it can't be used outside of here, so I can't say I equals 2. It won't like it. It's not there. I can't do. I can make one up here, but it still kind of doesn't really like it. You can do it. I'm going to say, as long as this integer variable is less than the total number of points in this array that I have, loop over it. Keep going over each point. And this I here is going to say, at the end of this loop here, increment the I value, and loop over it again. And then it will check this statement here. So this is basically saying, let's just say this line here is going to be line 1. I'm going to say int I equals 0. I'm going to do some functions here. I'm then going to say I plus equals, or I equals I plus 1. And then I'm going to say if the current value of I is less than the length of PC, then just go back to line 1. That's what it's doing. It's all it's doing. Okay, so that's the for loop. I need to reset this. And what I want to do now is I want to say I'm also going to encapsulate this inside another if statement. So I'm going to say if the length of PC is greater than 0. And this is what I was doing over here. With this PC number found, I said, is it greater than 0? If it is, do this. So I'm going to go back. I'm just going to tap these in a bit. I'm hopefully you're not. I really hope you're not getting lost on the Vex too, because it can be a little daunting. And what I want to do here is I want to get a positional variable. So I'm going to start out. I'm going to say vector is pos. I'm going to just set it to 0 all the time. And so for this position, I'm then going to say position. And what I could do is I can either say equals position plus this, but a shorthand way of doing that is I can say plus equals. And then I want to get the variable of the point that I'm getting. So I'm going to say point. Point is going to give us the attribute from another input. I'm going to say 1 because I want to get the position from these points. I'm going to say p because that's the variable or the attribute I want to get. And then to get the correct number, the correct point, I'm going to say pc square brackets, and inside the square brackets I'm going to put our I variable. That's going to give us a positional. And then what I'm going to do is I'm going to say position. I can say divide equals. It's going to be the same as saying position equals position divided by something, divided by the length of the PC. Okay, so that's our positional variable. That's what this PC filter is actually doing. And I'm writing it out in full hand here because it's so you can understand exactly. And I think I'm going a bit long. Okay, now that we've got that, I want to get the distance between this and our current point. So I can say the float of distance is going to be the distance between my attribute P and this position. Then I can just say at CD equals dist. And we're going to see nothing. So what I want to do is I want to say 0.1. And I want to dive up and see if that's working. It's not. Let's dive back in and figure out why. So position plus equals that. Position 1. It's doing a for loop. If the length of PC is greater than 0, yes, then CD equals dist. CD plus equals dist. So I want to actually add to that. And we can see it's now adding to this. But it's also adding it in this stepping motion. So what we want to do now, I'm also going to see what happens if I -1 it. And I'll explain that in a second. So what we're doing here is we're paint will help me. Okay, so imagine we have values here of like 0, 1, 2, 3. In computer programming, we always start our numbers at 0. However, when we count them, so we're counting the values. So this is going to be counted as 1. So that we found one value in this array. This is going to be a second value. This is a third value, fourth value, and so on. And so that's why inside here I did II is less than the length of this, because the length is just going to count how many there are. It's not going to subtract 1. If I was doing it silly, I would say if II is less than or equal to the length of PC. And what that's going to do is it'll make an out of bounds error. It's going to try and access a point that doesn't exist in the array. So when I'm doing this length divided minus 1 here, is because I'm getting positional values. So I'm going to say, let's say 1. I'm just going to do the x. So say 1, this one was 3, this one was 2 here. So we're going to get about 6 all up. And I want to get the average of this. So I'm going to say 6 divided by, okay, it's 3. 6 divided by 3 is, well, that doesn't make quite so much sense, but it is actually working inside this. It's kind of different how it's working inside of here. So we want to say 1, 2, 3, because we're getting 3 values. Then we're going to get the correct value, which is 2. However, it's not going to work quite that way inside here, so we just minus 1. So that we get the correct value that we're having. Okay, now with the distance, we have to also do that fit range thing. So I'm going to say fit between 0 and the radius, 0 and 1. So, and now we're getting this. And because we're adding it to it, we're going to get values of like 46, which isn't what we want. So what I'm going to do is I'm just going to say at CD clamp, the at CD between 0 and 1. And so this way it won't go above 1. Now, but I still want to get like this noise variation. So I'll showcase how we can do that without doing all that noise inside here. So I'm going to say, I'm going to lay down a noise, an attribute noise in here. I'm also going to lay down a rest position. So actually I'm going to put these, actually I don't need the rest there. So I'm going to make a rest in here. This is going to take copy the positional variables and add it to an attribute called rest here. I'm then going to noise up the position a little bit. I don't really want to touch the y value, but it seems I don't really have a choice. Or do I? Brilliant. Not giving me the option to change the y variable, which is not quite nice of it. Let's make that 0. Nope, not letting me change that variable, and it's going to keep adding to that. What I want to do is, after I've done this, I want to say at p equals b at rest. That's just going. That should reset it back to there. Cool. Now, ideally, what should happen is it should grow. But because we're moving it across the y, it's not going to work. So I need to flatten the y variable, and it would honestly be really nice if it would let me do that. Oh, there's the amplitude here, and I can just push down the y like so. And this is adding to it. We don't really want to add, so let's say 0 centered. So that way it's going. So that way, if it was 0 and 1, you will see that it's actually going up and down to 0 and 1. So I'm just going to say 0. The attribute. Let's block that up, and then I'm just going to bring this element scale up a little bit and turn the amplitude down just a little bit as well. And now we get that, we should be seeing this type of growth appearing. Cool. Another method you could do as well to make sure that we don't get this going over time, because this should technically, this should be staying. So what I'm going to do is I'm going to say offset. I want to say animation, and I want to animate the noise. Okay, so that's the growth technique. And this technique is something we can use wherever you want it to be. Ooh. Is there any questions so far? Check YouTube. Oh, hello, everybody. Average watch time is 12 minutes. How long have I been streaming for? An hour. Okay. So I'm going to call this the growth. So, and I'm just going to keep it like this. So now that we've got this growth working, we might also want to have it timing itself, but not right now. So another question was, how do we scale it back? Or how do we scale it down in a way? So what I'm going to do now is I'm going to make a box. And inside this box, I am going to make it about 5. So, and then I'm just going to cut it up. And I'm not going to bother with so I also need to do a VUE so that we're getting points inside here. Sorry, I just had to swallow something. Okay, so let's take a look at this scatter. Yep, cool. So now we're getting this Voronoi here. I'm going to push this to the side a little bit. And the side here, no question of effects, great. Good to know that I was actually able to teach that well. I'm just going to put down explode so we can see the exploded view. Cool. And what I want to do is I want to add a point where all these are. And there's several ways you can do this. There is always several ways you can do this, but I'm going to show a way that I tend to do it, which is to go to make a assemble node. We're getting to the right one. I'm going to create pack geometry, and this is going to give us all. This is going to give us as just points basically. And what I want to do, I'm also want to keep the name. So I could either side here do a. So I'm going to do a for loop. So I'm going to say for each named one. I'm going to plug it in. Because it's packed, it's not going to quite work. So what I'm going to do, I'm going to say, what's the easiest way to do this? Yeah, I'm going to do a for loop. This is the easiest way. And instead of packing it straight away, I'm going to pack it afterwards. I'm going to turn off the name because I don't want to change the name just yet, because the name is currently working. Okay, now that we've got that, what I want to do is I want to put down an add node. I'm going to go over to here. I'm going to say this add node. I'm going to select add spare input. I'm going to plug it in here. And then I'm going to set this assemble. And inside this one, we're going to see we have a point, and each point has their own positional value. But we're only running on one point because we're going over the name and we're packing it. So what I can do is I can say point -1, and I'll show you -1 in a second. So -1 is going to get the spare input here. I don't want to plug it into here because I'm still going to get variables along the right for it. I'm going to say -1. I want to get the current point number that I'm working with, and because I'm only working with 1 point in this for loop, I can just say 0. And then I want to get the value that I want to get the attribute name. So that attribute name is just going to be P. And then I want to get the component. The component is the X, Y, or Z. And that's represented as 0, 1, or 2. So I'm going to say 0. And I forgot to put the bracket in. And now we should be getting a point somewhere down this line here. Over here, where the point is on the X axis. It's not showing it to me. Cool. So I'm just going to copy paste this. Say 1. Paste this. Say 2. And I'm just going to go to my forward loop. And now we're going to see that we have these points where these ones were. Now there's one thing missing. We don't have a name anymore. So what we can do is we can just do a transfer attribute transfer. And this should now give us the name. We don't want the path though, so I'm just going to turn off primitives because I just want the name attribute. So each point now has their own separate name. And I can now join these points up to the name. But this is a way so that we can get the way we can get that basically. The reason I showed you this is I can't remember why I showed you it now. So let's just quickly start by showing a very basic scaling down method. I don't know why I showed you that. It's quite annoying. My mind's just gone blank. So I'm going to put down an assemble node. I'm going to pack it. I'm going to turn off the create name because I don't care about the name currently. And what I'm going to do is I'm just going to put down a dot network. Inside this dot network, I'm going to say we can use either points, particles, or RBD. I am going to use the RBD for now. So let's say packed object. Oops. I'm going to say rigid body solver. I'm going to say first input. Nothing's going to happen when I press play. Although that is a very slow one, which is kind of weird. Why is that so slow? Normally it's a lot faster. That is very weird. And then what I want to do, actually let's just take a look at the guide geometry quickly. Not seeing any guide geometry, great. Why am I not seeing any guide geometry? Okay. Turn it off. There we go. The reason it was slow is because it was still trying to give me the oh, it's still slow. Okay. Maybe the version I've got is cut down on something. Anyway, what I'm going to do is I just want this top layer here to just spin off into wherever. So I can say RBD, I can say pop group. And I can either put it in the post solve or pre-solve. I'm going to put it in the pre-solve. Later, merge node. I'm going to put in a bounding region here. I'm going to say bounding sphere. I'm just going to bring that up. I'm going to make the size a little bit bigger. And I'm just doing this because just to show how to do the scaling effect. I'm just going to put it there. And so now all these points are going to be in that group. What I want to do is I want to say group name is affected. I'm going to lay down not a gravity, but I want to lay down a pop force. And this pop force, I am just going to say force of let's say 5. That's going to push it upwards. So if I just press that, it should ideally push it upwards. So yep, you're seeing the whole thing being pushed upwards. I just want the group of affected to be pushed upwards. And we can see that that is now being pushed up. and the group is pushing away those that aren't being affected as well. Okay. So what I want to do is I want to age these. Who is messaged me now? Machine destruction. That's Saber. Okay. So I want to age these points if they're in the group. So the way I can do that is I can say I can put down a pop wrangle. And the way we age points is we can either use the actual age or we can use the frames. And so what I want to do here is I want to say if we're going to say attribute group, and this is how we say if it's in a group, we say if at group underscore then the group name which is affected is equal to 1, then I'm going to say a new age. So I'm going to say f equals let's say applied age. I'm not really good with numbers with things like this. And then what I can do is I can say at time inc, which is the incremental time of, or how long each frame increments by. So ideally, if I now press pause, actually I'm going to animate this down as well. So what I can do is I can turn this off. I'm going to push this up. I'm going to animate it down. I'm just going to animate it down to be about there. Like that. And so now I can actually get a good reading is if this is actually getting the attribute applied to it. So I don't want to say equals time increment either. I actually want to say plus equals. So it's going to be incrementally adding to it each time. So I'm just going to run it. Hello, Francis. Good of you to join us. All the way over there in the land of Italy. So I'm going to go into the geometry spreadsheet. I'm going to go down to my geometry. See, we've got the active attribute here, and we've got applied age, and we can see that some of these have got a greater applied age than others. Cool. So I'm going to be using that later. Now what we want to do is I want to bring this out, and I want to scale. If I want to scale them down based on a range in that age. So I'm going to say dot import fields. I'm going to say dot import actually. I'm going to plug this in. I'm going to say pop packed object 1, or is it RBD object 1? RBD packed object. Completely got the right name wrong. Okay, I'm going to say create points to represent geometry. Now we can see the points coming in. What I want to do is I want to say transform pieces, and I'm going to plug this one in here and plug this one in here, and now we're going to see that's working. And I believe what you can do, which I'm not going to do right now, but I believe we can say at p scale equals, let's say half, and it actually will scale it down for us. But if you don't have access to that, I'm going to show how you do it another way. So I want to transfer the attributes to copy. I want to copy over the, so let's transfer attributes. I want to copy over the applied age. So now this has applied age to the point. I'm going to say applied age. So now these all have points. I'm then going to put down a color so I can visualize it. I'm going to say ramp from attribute, and I'm going to say applied age. And we're not going to see anything because we need to promote that to a primitive, which is really annoying. Oh, wait, the color. There we go. Not that. It's a little annoying, but that's how you have to do it. Okay, there we go. And what we can do is if I put this out here, I'm going to lay down a point bob. I'm also going to unpack these because we can't really do this inside of packed geometry. And I'm going to put the first one in there. I'm going to turn this on, so now we're dealing with the raw geometry properly. And what I want to do is I want to just do like a scaling effect. And what we can do, how we can do that is we can say transform matrix. And don't be scared about that, the name. It's literally just a transform node inside of a VOP. And what we do is put position in here and position out there. And I can scale it down here. And you can see it's scaling down to the middle. Not really what we want. We want to scale it down around its pivot. We want to set the pivot. And the way we can do that is we need to find the position of these points here. So these all have their own little position, and I want to find that one, because this is just one point here. And what I want to do is I want to find that point by the same name, because this one has the name here, the primitive attributes of name, and this one has the point attribute of name. So I want to match up the primitives and to the points with the same name. And the way we can do that is we can use something called a find attribute value. So what we do is we say it's a string attribute. The geometry file that we want to look for is the second input here. The attribute class is the point. The attribute is the name, and the search value is our current name. So ideally, then what we can do is we can say, I'm not going to plug in anything yet. I'm going to say import point attribute, element ID of point number, file is the second input, and that's going to be the position there. So now, ideally, nope. So I need to actually give it my current name. So we're dealing with the points, and we need to find the primitive name here. So ideally, what we could do is we could just promote these back. So let's just try that first. Let's go attribute promote, and I'm going to say primitive to point, and I'm going to say name. Let's try scaling it down now. Nope. So I'm going to say bind, plug in the search value. I'm going to say it is a string, and I'm going to say name. And now we can see it is actually doing this. If we didn't want to do promote, because sometimes that cannot work, what we could do is we could say prim. We can get a primitive attribute here. Wrong thing. You can say prim point prim. Yes. So there's a proper way of doing invex, and the way we do it in vex is we say attribute wrangle. We can say prim points, and what that'll give us is if we're going over primitives, it will give us the list of all the points that primitive has. We've got the point prims, which if we're going over points, it will give us the primitive number. So that's not right. No, it's not quite what we want. So let's try and figure out what the equivalent would be in VOPs. So let's take a look. Just quickly going to the documentation. Brilliant. There is nothing there, it says. So let's try and find another one. I believe we could just say import the prim, but that shouldn't really get what we want. Maybe this might be it. So point primitive, let's say this is our point, this is a vertex number. The vector, so we want to get the positional. No, we want to get the name. Attribute class is primitive. Signature is a string. Is the first input, and we can say search data for there. And we've got to turn off the promote. Okay, fair enough. So it probably is better to just use the promote then. And so now what we can do, now that we've got this scaling effect, which isn't working, now that we've got the scaling effect, what we can do is we can say bind import the affected age. How do I spell it? Applied age. Plugged into the scale. And because this is a float and this is going to a vector, we need to actually go float to vector. And because this isn't seem to be working, why aren't you working? Where are you? To be honest. So what we could also do is instead of this here, instead of this applied age from this bind, we could import the applied age from here, which should be a float value, and we can see it's getting the inverse of what we want. So let's just reverse that. So I'm going to say fit range. I want to fit it between, honestly, I'm going to plug it in here. I want to fit it between like that, and the source max, I can set it to be about 1.2. And now the longer it's been in there, the smaller it's going to get. But because we've also got this working here as p scale, we could also just do it in here. So I can say applied age. Oops, I can even turn off this as well. So f at applied age. I can say f at p scale equals that. How about we fit range this between from, so I can say channel float min, channel float max, between 1 and 0. I think that's correct. Yep. Now what I can do is I can set, okay, if it's been longer than, let's say 1.6, then it will actually disappear for good. But hopefully it is still actually aging on. And then we can say if it goes on longer than is needed, then we can just delete the point as well. It seems to be stopping too. So let's take a look to see why. Yes. So the applied age just seems to be stopping completely. So let's take a look into why. So it's saying if group affected, or else if f at applied age is greater than 0, then keep on doing it, because I have a feeling that once it goes out of that bounding box range, it doesn't preserve itself. I can actually set it onto preserving it, so let's just do that instead. So it was just stopped. It was stopping aging itself. And now you can see it is scaling itself as it goes up. And if we wanted to, we can turn this off. So yes, and this is going to do the exact same result as well. Let's promote those fit parameters up too. So let's say it starts scaling from about 1 to about 3. Or not even that, let's say 2. It's a bit sharp, honestly. So if we wanted to make it a little less sharper, because we're going from 0 to 1, let's invert that again. Let's do a channel ramp here, and let's do another fit range here. I'm going to change to a spline ramp, and then I'm going to invert it here. Okay. So now I can adjust this a little bit. And instead of it being so sharp, I'm hoping doesn't seem to be having any effect on it whatsoever. Okay, that would help if I actually plugged it in. Then we can have some sort of effect to it. So I'm going to make this a B-spline, this one a B-spline, like this, and then I can add a smooth fall off to it, so it's not as drastic really. So now we've got this nice scaling effect. These ones aren't being affected by it, which is a little annoying because we do actually want them to be affected. So what we want to do now is we want to combine what we've got going on here with our growth solver. So instead of, pardon me, instead of doing a group, we're going to use the growth solver inside here. So let's get started on doing something like that. So that's the theory, basically. So that's all the testing done. So let's actually start working on the actual geometry itself. So I'm going to use, let's see what we've got in test geometry. So we've got a template head, we've got, let's just go with the template head for now. Zoom in on that, it's lovely and ugly. How big is this? About the size of a head, really. So let's keep it the size of the head. One thing I'm going to do is I'm going to close it. So I'm going to say fill hole, polyfill, and I'm going to set it to triangles. I could also just set it to a single polygon, honestly, but it's better to just set it to triangles here. So that's all the prep I'm going to do for that. One thing I might want to do is just remesh it so that I know what it's doing. I also probably don't need the inside of the mouth, to be honest. So let's actually just delete that before we do the polyfill, because we can do the polyfill after. So I'm going to blast. I'm going to select the geometry. Why can't you do rings? Where's the ring attribute? Select. Thought there was a way to select by a ring. It doesn't seem to be, which is a little annoying. So let's go like that, and I'm going to select around. A little hard to select around the mouth, honestly. So I'm going to select right there. Oops. If I keep selecting them, then what should happen is, oops, not that one, is it should just delete all of them, but it won't, because it's always been stingy that way. So let's try a different method. Okay, so select that one and then select this one. And then I want to select that and then select this one as well. And let's hit enter for that. And so that's going to close off this. And then I can just do another blast because it's now been isolated. This is just general cleanup of the geometry. So if you know, it'll be over as soon as I can. Then I can do a polyfill. And it's not going to like it because some geometry is left over. So the way we can fix that, if I recall. Also, that's a little weird why it's doing it like that. So let's try again. Just deleting these edges here. So let's make them the points too. Just going to select the edges instead. Going to say select. Can I not select them to the points? Convert that to the points. I don't think I can. Doesn't look like I can. Who's messaging me now? What a professional, thank you. I don't. I know that's you're being sarcastic, boy. Yep. Let's just use that one. Then with a blast, I'm just going to select all of them. And now what I want to do is I want to delete that NURBS-like surface there. Not too sure how I can do that. Let's take a look at a. So this is the problem with like using edges to delete. Really, I would normally just use the points. I suppose that works. If I just get rid of that, then it's just going to say, yep, this is the isolated version. So now I've actually isolated the mouth as well, because I don't really want that big of a mouth. Okay. Now what I'm going to do is I want a little bit more geometry to work with, so I'm just going to put down remesh. I'm going to set that down a little bit smaller. Maybe a bit too small. Honestly, I don't really need. Honestly, I don't really need that one. To be honest, I'm just fooling around now. I want to just Voronoi this up once because we're going to do a secondary Voronoi on it. So I'm going to do VDB from particles. Polygons, I mean. Set the scale down a little bit, and then I'm going to set it to density, and we see absolutely nothing. Scatter. Say fill interior, and I'm going to randomize this down to about 3. Little extrude is enough. Yes, true. But for now, I'm just going to do it this way. I'm going to do Voronoi fracture. Yep. And I just want to see split view, how many pieces that is. Okay, maybe I will put that back up to 10 because I want more even pieces. Let's go 2,000 pieces. So we're not going to get 2,000 pieces, obviously. We're going to get either a little bit more or a little bit less. This is the way Voronoi works. But that's basically what I wanted. Okay. Now what I want to do is I want to have that growth solvent. I want to, let's start it from about here. Honestly, we might need a bit more of these. So let's bring it to about 8,000. Because we can fracture it even smaller later down the line. Okay. And let's just take a look at the exploded view. Yep. So we're going to get a lot of points on the inside, which is why I can see you suggested just to do the extrude. So let us just try the extrude for now. Poly extrude. Yes. Maybe a bit too much, too less. Upper back. Let's just reverse that. Okay. So let's just try that then, where we just have it around the edges. So we might have too many Voronoi pieces now because we're scattering 8,000 pieces across it. So let's just wait for that to cook. Yeah, that's a little bit too much. So let's cut that down to about 5,000. Because we do want some larger chunks here and there. That didn't make a visually, well, to my eyes, difference. But okay, let's roll with it. There's these pieces out here too, which are a little weird, which I don't like. Was that happening with the polyfill? Let's take a look. Oh, I suppose you would be able to tell, would you? Because the whole thing's been fractured up. Some of those points, though, are a bit disturbing. So, we're going to have to clean that up. How would you clean that up? Got any ideas, Francis? Reduce the extrude, you reckon? Okay, well, let's try that. Let's turn that off. Let's go down to 2000. Yeah, okay, so that has worked. Then, cool. Let's go back to you. And we're now going to apply our little growth solver that we have. And let's say we want to start from about here. And what we want to do is I want to make a point for each of these, which that's why I did that. That's why I did this thing here, so that I could make a point and then we could grow by that point. Let's copy paste this, which if you don't remember, I did a for each piece over the over each name. Over the assemble, I just packed it. Using an add node, I grabbed the position of the point and just made a new point, and then I transferred the name over. So now we've got the name there. You can see we don't have that many points, but that's fine. We can add more if we need it. Actually, let's add a bit more. You can see the Voronoi is struggling just a little bit. Okay. There we go. So now that we've got that, let's add our growth solver. So I'm going to grab, let's grab this entire thing. So now we want to group the correct ones, and our sphere is way over there. It's massive. So I'm going to turn off this mountain first, and I'm going to reduce this down. And honestly, I could probably make this make the head bigger and do all the stuff there. And I may end up doing that, honestly, because scale is quite an important thing when it comes to doing all this. So let's transform it. Could I just transform it from here? Let's make it 10 times the size. Make sure the blast still gets the right ones. Yep. Poly extrudes. So we can probably make the poly extrude a little bit more. So I'm going to make it about that much. Let's do our Voronoi fracture. Okay. Let's do our for each so we can see the points. There they are. And now we can finally see our sphere, which is, where is it? What the heck is that sphere? All the way over there. All right, let's make that a little bit bigger, just so that I can see what I'm doing. I'm going to go to the top view, press enter, and I'm just going to move it. And if you've ever seen me using Houdini before, you know it's very rare that I actually use the move tool. So I'm just going to scale this down. I'm going to go from grey to my dark mode so I can see the points a lot easier. That background's better for, let's say, volumes. Just going to scoot it over a little bit more. And let's scoot it down a little bit. Okay, so now if we group it, we're going to see we're going to be grabbing a few points. Let's color those points. Kind of hard to see now, so let's go back to my grey. Now we're going to see that. Let's add a mountain. Maybe let's not add a mountain. Let's turn that down a little bit. And this will be great if we turn up the scatter. So let's turn up the scatter again. So let's go back 8,000. Just going to wait for the good old drawing reflection to actually run its process, and then the for each through it. Okay. Now, if we go to a solver, we can see it is going quite fast, which is what we want. We want it to be a bit slower than that. So, to start out with, let's go to our attribute P first. Let's make the scale. So we don't want to change, we can change the Y as well now. So let's see, elemental scale, that. I'm going to make this here. I'm just going to scale this down a little bit. I'm going to make this a lot smaller. I'm just going to scale this down just a little bit, like so. I'm going to go back to the growth. And the radius is probably a little bit too harsh. Yeah, just maybe just a little bit too much. So let's, I'm going to go back here and I'm going to lock this so I can see what I'm doing. See if the scale is even going to register it. Nope, it's too small. That's a little, that's what we're getting there. That's a bit too fast. There we go. I think that one looks quite well, nice. You can see it's still, some of these points aren't still getting it. So let's do the pulse duration. Let's turn it down by a little bit. I can't remember if the pulse duration is up or down. Okay. Cool. There we go. So now, what we can do is inside this, we can say if the attribute of the CD is greater than, say, 0.5, then it's active. So I'm going to say attribute wrangle. Actually, instead of, before we do all that, I'm going to go down to here, and because we've already got our names, I'm going to grab down to here. I'm going to say assemble. Don't need to create a new name attribute. I'm going to say create packed attribute. And then I'm going to do the same thing that we did with the this thing, where we did this find attribute value. Now I'm just going to showcase it in Vex, which is very easy to do. We just say find attrib. Well, if we stop here, then we're going to see all the values that it takes in. So we can see it takes in the geometry, the string attribute class, so if it's going to be points, primitive, detail, etc. The name of it, the value that we're looking for as well. So we can either find the attribute value or the array. We don't want to find an array, we just want to find one. So we're going to say we want the point, the name of the attribute to read, and the value we've got. So under this, I'm going to say 1. I want to find the point with the same name. So I'm going to say point. So I think it's s at name here, and then nope, I've done it wrong. So after point, I say the name, and then I get this. Then I say the value that we're searching for. So I'm then going to say int point. So I'm going to be finding the point that's going to match that name. So I'm going to say name. Then with that, I can now say at CD equals the point 1, the color of that current point. And it's going to be completely black for now until it gets a majority white. And what we can do is we can say color. Actually, no, we can say attribute promote, because we need to promote the color from point to a primitive. And now we can see it's growing. And now that we've got that color, so I'm going to say vector c. I'm going to say if c.x is greater than 0.5, then active equals 1. Actually, I'm going to say at active equals 1, else at active equals 0. Or I could just say at active equals 0. If it equals 1, then just set it to 1. So now, take a look. I believe, so I'm pretty sure active has to be an integer value. So let us check. At active value. Okay. Yes, so it doesn't exactly say what type it should be. It just says if it's greater than 1. Or if it's greater than, if it's greater than 1, then it is active. Okay, we've got active value, and active value is off. Cool. So let's bring that into the dot network. So we've got the active, got the name, and we've got everything else we need. So I'm just going to say dot network. Fire it up. I'm going to put down a gravity. I'm going to put down a packed object. I'm going to say rigid body. And I'm going to say the first context, please. And I forgot I need to turn off this first. And I'm pretty sure what should happen now is our active should technically start to go away, but it's not, because we need to say it's a need to overwrite these attributes. So I'm going to say active, and ideally what should be happening now is the active should be coming across. Let's make sure the active is actually coming across here from our solver. So let's actually cache this to the disk. So I'm going to say sim solver active. $F4. I'm going to hit save to disk. I'm going to say oops. I'm going to here, I'm going to say initialize the simulation ops. So I'm going to reset the simulation first. Then I'm going to say save the disk. And now when I load it, it should be getting this. So now I'm going to visualize the active attributes. So let's say active, color attribute, ramped attribute. Yeah, getting the active attribute, and then promote parameter. So, oops, nope, that's not what we want. I want to say at cd equals 1, or cd equals so, and then I'm going to say at cd equals 0 for starters, and then at promote from point to primitive, and now we should be, so our active is working. Okay, active is working fine. Let's go back. I'm going to turn off the color because I don't really want to see that. So the corner of my mouth has started to crack, which is basically what we do want, but nothing else is coming in. To reset the simulation, we normally have to turn that off and on again. So that's not working. Okay, static object off, on again. It's a little unusual why it's doing that. Okay, active objects, I believe, it specifies this the point attributes. I'm a little unsure as to why it's not grabbing it every frame. That's very annoying. Why it's not grabbing it every frame. So what are the defaults? Revert to defaults. Active, animated, deforming. So I have a feeling, when I did this last time with another student, we might need to have animated on as well. So I'm going to say animated equals 0. Animated equals 0. But that shouldn't technically be it. However, because it's not working right now, there is another method we can use. So inside of here, I'm going to cut that. I'm just going to cut it out. I'm going to put down a null here, and I'm going to say out solver. I'm going to color that one nice green. I'm going to color this one red. This is going to be a primary fracture. Primary fracture. Keep that, and I'm going to keep the assemble. And what I'm going to do is, the whole thing should be just start falling down currently. What I want to do is I'm going to say create static objects. And what that means is it's going to set the active to 0. So I'm then going to do is it a solver that I want, or is it a pop solver? I don't think it's a pop solver. No, not pop solver. Sorry. Was it that I wanted? Let's take a look. We've got the solver, a static solver, a stop solver. Might be a stop solver that we want. Nope, not the stop solver. So I want it to be like a I can only just remember what it was that we need. So the active value is not what we want. There was a specific solver that we would use. So we could use a pop wrangle here. Might just be a VOP. Nope. So forces, force, fields, data flows. Don't think it was any of those. That's very annoying. I've always had trouble with that animated versus active part where it just doesn't want to behave itself. All right, trying to go back to Google to figure out what that solver was that called. Is it merge? Nope. Okay, rigid body. Hmm. It might actually just be the subsolver. Yeah, it might just be the subsolver. Okay, so let's go into the subsolver here. Who's messaged me? Use pop node group, yes, but I want to set the active using that growth solver we had. So we want to use the dot network, and the dot network is going to give us the packed geometry here. And so what I can then do is I can just copy paste this here. And now I can set it to active. What I want to active and what I want to inactive. So, or I can say active plus, and then I can say active equals clamp between active 0 and 1. So that way it's just going to be, it's always going to be 1. And then I need to do an object merge. Inside this object merge, I want to go up, up, up. Nope. Where is it? Out solver. Okay, let's try that. And there we go. We're now getting our growth solver giving us this active objects here. So this is just going to be falling down. Not quite what we wanted it to do. So what we can do instead is we've got several options in advecting it outwards, but this way it's doing like this growth on the overall geometry, and you can see it is taking its time, which is really annoying. So let's, instead of having the gravity affect it that, let's give it some age. And remember the age, the way we do age is we say if c.x is greater than 0.5, then we say f that, let's say, let's give it a new name. What name should we give it? pH, let's say pH plus equals at time inc, like so. And so now we should be getting an attribute in here. Can you put a pop force? Yes, this is exactly what I'm going to do. But the reason I'm adding an age first is because I want to drive the pop force with the age. So I'm going to say pop force. I'm going to put that in merge. I'm basically going to do everything in the pre-solve instead of the post-solve. You can do it either way, honestly. I'm going to put down active. And so that's going to start affecting those pieces immediately, which isn't always what we want. I'm very annoyed how slow it's taking. So I can use this expressions here, where I can just say, yep, amplitude by the age. And instead of amplitude by age, I can use my new attribute, which if I go into my geometry spreadsheet, go into RBD packed object, and go into geometry, we should now see a new age variable, pH. Yep, and the pH is actually going on. Also, I'm also going to say if f at pH is greater than 0, then do that as well. So that way, even if the color kind of just stops, it'll still be going on. So that's that group thing as well. So I'm going to say at pH, going to keep it to F, and now it's going to smoothly go from the ages of 0 to 1.5. It's going to no, from the age of 0 to 1 as it goes. It's now going to go from the amplitude is going to go from timesing it by nothing to 1.5. So if I say 50, actually I'm going to say 5, and I'm going to say 15 upwards. And unfortunately, this force and this amplitude are two different things, I believe. So what I'll need to do is I need to do the same thing here, except I can't really do anything. So I need to say randomize magnitude. So we're getting something like this. And what I want to do instead is I just want to say, oh, smooth it between this. So I'm going to say smooth between these two here. So now that should be smoothly adding to it as it gets older. We can see it's kind of as it gets older now, it's starting to really be pushed upwards. Okay. So instead of going upwards, I want it to go in a more x plus z way. So I'm going to say 1 by 1. I'm also going to put the swirl scale up to 5. I'm going to put this up by 15. I can also, if I wanted to, make this, the noise, go from 1 to about, actually no, from 0. Still want to go from 1, that to 1. I can fit range this. So I'm going to say fit range from, let's say, 1 to 3 to 0 to 1 again. So it's the smooth is always going to take a 0 to 1 value. If the age goes over 1, it's going to use that as well. But I just want it to go from 0 to 1. And I'm going to say if I'm going to fit the ages between 1 and 3. It'd be lovely if it was a bit faster. Sometimes turning off the display geometry makes it go faster, but it doesn't seem to be helping. So what's happening here is why it's pushing out so fast is because of the noise. So let's turn that down to maybe about 3. And let's fit range this one as well. So I'm going to say fit. Let's say 0.5 to instead, 0.5 to 1.5. So what can happen here is between these ages, I can just say, oh, just make it full maybe a little bit. So that still might be a bit too much with the forces. So the forces are a bit tricky to really deal with, honestly, inside of pops. So what I tend to do is I use a volume, but even then that can be a bit tricky. So as you can see here, this is still this is still kind of being affected, sort of thing. Um, but it is working, kind of ominously. So I might change this down a little bit. Yes, maybe change this to 1.5 instead. Okay, let's make the turbulence a bit higher. I used to have a very old computer. Still, well, technically, I'd say nowadays I don't really have an old computer now, but students sometimes send me files that fill up my RAM. If you don't know my RAM is 128. They fill it up completely. I'm looking at you, Francis. Um, you tend to fill up my computer, and my CPU is not too bad as well, but at times it can still get a bit heavy. So a custom that I used to do was I used to click where the end was of the frame range that I wanted to view at, and just go from there. So now that, it's still quite harsh, isn't it? But it still looks kind of nice. But I'm going to show another way of doing that breaking effect very quickly. So let's go down to this Rhino effect. So let's go down to this VDB actually. So this is our VDB. Come on, if it will actually work. And I actually don't need this. What I do want is I want the polyfill here. So I'm going to go back to here. I'm going to say polyfill. I'm going to do the VDB from polygons. And I'm going to scale it down a bit. Honestly, this can probably do with less of the scaling here because this is quite harsh, 0.03. I'm just going to turn this into density as well. I can fill the interior too, but we're going to see something very nice like that. That's my graphics card trying to keep up. So let's try and optimize this a little bit. People keep messaging me. Where is it? Material, background, scene. Nope. Geometry, volume, high. Let's go down to... Where is it? So we've got a limit texture resolution, that's fine. That's fine. Yeah, okay, that's... It's just not showcasing very well. Someone is messaging me. It's my little sister. So it doesn't look very nice. But I do want to have it fill the interior. Because what I'm going to do is I'm going to say attribute, I'm going to say P, and I'm going to make a velocity field. And we can see we're getting something like this here. I'm going to change my material from grey to dark. That hasn't helped it in the slightest, has it? I have a feeling it's because I've got a LUT. So I'm not too sure why it's doing. Oh, hang on. View. Yeah, neither. Nope. Far clip. Near clip. Near bar. Back to the others. Okay, that's a little unusual. Okay, now it looks a little bit better. If I'm that close, it looks alright. So we can see we're getting this extra thing here. I'm going to turn it off for now. Actually, no, keep it on because I need it. We got this extra field, and this is just the way Houdini can showcase a vector field. So what I'm going to do, and a vector field is a free floated field. Houdini natively cannot handle free floated fields, so which is why we're using a VDB. VDB is from the open source VDB. Who made VDB? I think it was like a mixture of a few people. So predominantly DreamWorks made it, but it has had help from a lot of other companies. So let's take a look under the About section of OpenVDB. If you can't tell, I really like OpenVDB. So you've got Pixar and Solid Angle, the people from Arnold, Digital Domain, ILM. They all contributed, but the main creator was DreamWorks. So, and the beauty of being able to handle this is it just means it's a lot easier on the memory. And I hope what should be happening now is that it will be filling this. I don't think it is, so what I'm going to do is I'm going to do a box. I'm going to do a bounding object. The reason I'm doing a bounding object, and I'll showcase in a second why I'm doing a bounding object, is if I lay down a tree. Now the tree is going to show us what voxels are active and what voxels are not active. And as we can see, it's made this lovely little cube, which is why it's so impressive and fast and memory efficient. It's because it doesn't fill the entire box with voxels, it just fills what's needed. However, I do want the entire box to be filled, so I'm just going to put down a bound. And so now that's going to fill the entire thing. And I might even make it a little bit bigger. So the way we do that is we just add to the lower padding and the upper padding. So I'm going to set it to be about 2. So it's going to be a bit bigger. And the VDB from Polygons is struggling to make a VDB at that resolution. Something you know a lot about, isn't it, Francis? You know? Oh, it's frozen my computer. So I will need to lower the resolution on this, which is rather annoying. So I'm going to lower the resolution. We don't really need it that high just yet. So something's probably wrong with my computer. Honestly, I do a lot of development on this, so I probably mucked it up a bit. But that shouldn't be taking so long to do this. I have a feeling it might also be just the daily build I've got. I grabbed the latest daily build. If I reopened my computer, if I reopened Houdini, would it crash? Using the other daily build I had. Okay, it didn't like some things. But yeah, the VDBs are a lot faster. Okay, so there's something wrong with that in particular. I'm just going to put it up to about 0.5 because it's a little heavy what I'm about to do. What I want to do is I want to create a noise field. And it's going to be a little bit easier than doing it inside of a point bop. So what I'm going to do is I'm going to use something called a volume bop. I'm going to plug these in. And the way I can, oh, my ears are hurting because of my headphones. The way we can visualize the velocity is using something called a volume, a volume trail. And what you have in here is you have the points and then you have the velocity volume. So I'm going to plug in the velocity here. I'm going to lay down a scatter node, plug it in here. So now we've got the points being scattered, and then we have the velocity coming in. And we can see it's just pointing outwards because that's just what the position is giving us, because we're setting the velocity to be the position, because we don't have any velocity. And I'm not going to give it any because I'm going to make my own. So what I'm going to do is I'm going to say bind export inside of my volume up. I'm going to set it to a free float vector. I'm going to say val. I can set it for free floats or just a vector. It doesn't matter. Then what I'm going to do is I'm going to say cool noise. Plug it in here. Then I'm going to add that into the position. And now we have our kill noise. I'm going to lower the frequency right down to be something like that. So I'm going to lower it down a little bit. Let's see what we can get. Something like that. And what this can do now is I can now bring this in as a secondary velocity. So I'm going to say out. And under the primary factor now, to stop that, get back. Oh, it's got to cut the pieces again. I probably should have saved out that geometry. So I'll go and actually save that out now. Where is it? Yeah. So file cache, plug you in here. Because it's a new version of Houdini, I'm just going to quickly resave out this cache as well. For now, I'm going to say geo. This is head fracture. .bo. Save current frame. I'm just going to save the disk. Load from disk. I've set initialize simulation operations on already. And I'm just going to cache that out. Okay. Dive inside here. And now let's just press play. Make sure it still works. Yep, it's still working. Okay. So instead of this pop force here, and instead of this, I'm also going to say create active objects. I'm going to lay down a pop vect by volumes. And what this is going to do is I'm going to say stop, I'm going to say up, out, loop, up again. Perhaps if I actually put in the full stops, out, val. And the field name is going to be velocity. It's just going to be an update as a force. It's going to treat it as a wind. It doesn't seem to be moving it at all. Which, as you know, always great to see. So let's try update velocity instead. and it's kind of moving. You can see some pieces are moving here. So the velocity is not that strong. Let's go update force to set the velocity to about 15. Now we can see it's kind of moving, but it's very, very slowly. Very, very slow, I should say. So we can fix that. Let's go up to our geometry here. To here, I should say. Let's take a look at that. So let's scale the frequency down. 0.25. Let's try it again. What a great face it had. um, so what it's going to do is it's just going to move along those paths. So if you want it to kind of infect a little bit more, you're going to have to update the this thing here. So we can do that by doing the offset. And what we can do with the offset is we can say constant vector. I'm just going to say it's a vector, and then I'm going to say add to the. So I'm going to say vector. There is a method here. So I'm going to say set vector component. I'm going to say new vector is going to go to the offset. The vector current is here. This value is going to be the current time. So now we're going to see it's flowing through the time, and it's currently just floating through the z-axis. I want it to be on the y-axis. Let's dive back into our dot network. Let's see it working. So I have set it up quite harsh too. That's fine. So now I'm going to add the SOP solver in again. And so now the SOP solver, actually, hang on. I've got to create these as static first, so that this can be overwritten all. So now we can see our pieces here are moving away. It's still a little bit harsh, so let's cut it down by about 4, and then what we can do is we can say do the same thing. If we say pass through, we're going to get the entire thing here. So we've got the force scale, the velocity scale is what we want. So vel scale is equal to this one here. What we had up in this pop force. Now you can see it's going from the age is actually taking it properly. Although it is moving it around in not a favourable way. So you could end up just using the pop force, honestly, if that's how you wanted it to work. Another way you can do it as well, which I'd like to showcase, is to have it rotate around itself. And I'll showcase how you do that. So what we're going to do is we're going to get in the polyfill, we're going to bring that into the second input. We're going to say, actually, no, we are actually going to use the polyfill, so something might happen, but I'm not too sure if it will. Instead of this kill noise, cut that off. I'm going to say another PC open. And in this one, actually no, instead of the PC open, there's an easy way. I want to get basically the normals of this geometry here. Oh no, we can't, unless we actually do a VDB, we can't actually do it from there. Okay, so we might just have to end up using this. So I'm going to say polyfill. We don't have normals, so I'm going to say facet. I'm going to make normals for this. So I'm going to say post compute normals, please. Doesn't look very nice, but we still need the normals. So I'm going to say PC. I'm going to say PC open. Go the visualization to that one. I'm going to say PC filter, and I want to get the normal. Plug it into there. File is the second input. Position is this position currently, and the scale can be as big as I want it. Let's make the scale about 5, 8, so that way it's just going to fill the entire volume. Or less. Let's make it less. So let's say about 1 for now. Let's scatter the points a bit more. So that's normals. I now want to do what we call a what's the name of it? Cross product. So if I make a cross product between this and let's say X, it's going to go across like that, or if we say Z, it's going to go across like that. I want to say by the Y. Another method we could do is we could say cross product between this and this PC filter, and then it's just going to go in like a downwards direction, which is kind of nice as well. Or this way. It's just very interesting to see the ways that we can do this. But for now, I just want it to go across the Y. I want it to rotate around itself. Like so. And what I could do here is I could then add noise to it. I'm also going to multiply this. So if I go PC filter, I'm going to say the distance between this and this currently here, and I'm going to use that as a multiply for this, and I want to invert that. So it's not an invert, it's a fit range. Let's do a fit range between this and the other one. Oops, wrong way around. Like that. Then let's turn the amplitude up. We can even cross product between a current position as well, which gives us this weird thing. I'm not too sure why this isn't working. Oh, hang on. Would help if that was like that, wouldn't it? And then we have to make the distance between this three about yay big sort of thing. And we also need to do that num found rubbish, which is annoying. So ideally we shouldn't need to do this. So let's turn that off. Let's go back to this add. Let's go PC open instead. And instead of, let's actually add a turbulent noise to the current position that we are getting our PC open from. Oops. And that wants to be a more nuanced noise like that. And it's still not quite working, so let's try, instead of adding the position, let's add it to the normal. Okay. So we don't need a noise, we don't need a secondary noise to it. We can add the noise later, but this is just going to give us this rotational effect. I'm going to turn this down from that 0.2 to 2, so it's a little bit faster. Depending on which way the normals are, it might render out the wrong way. So it's going that way, which is not really what we want. It is having like this it is having this curving effect, which is kind of nice to see. So what we can then do is, if we do want to have the that working, we can make another VDB here, grab this, and grab it from the polyfill instead. So now we're getting this one here, and we're just not going to have the velocity. I'm going to add this here, and inside this one, I want to say multiply by the third input. How do we get the third input of the volumes, though? Let's take a look at my YouTube to make sure everyone's still here. 2 people are viewing it. I think one of them are me. It's me. So I'm going to go multiply. I'm going to say volume sample. Volume sample is the way we get the volumes from second or third input, or whatever input. So I'm going to say third input. The primitive name is going to be density, and the sample position that we're sampling from is current position. And I'm going to say multiply. It is kind of annoying how it shrinks itself, though. So we don't want to multiply it by that. So I want to multiply current velocity from where we have it. So I'm going to say turbulent noise. Turbulent noise. Add it. So add that to here. Going to make it a sparse convolution, so it's going from 0 to 1. I'm also then just going to multiply you two together. And I believe we might need to scale it up. So transform and just scale it around this pivot, around this edge, I mean, using the expression CEX, CEY, and CEZ. I'm just going to scale it up. So look at this. Yeah. Okay. Yep. Let's take a look. Type noise. Let's push that up quite a bit. And the reason it's not really overtaking this is because this is quite heavy. So let's normalize this, starters. Make this a little bit bigger. Let's make that about 2 by 2 by 2. And that should do it, really. I wonder what happens if you put this in the cross product. Something weird. Cool. So that's what I wanted to do. I'm also going to reverse this. So let's say revert the gate. Set the gate. Which is just going to make it go the other way. Because I basically I just want it to go the other way. So it goes that way instead of this way. How long have I been streaming for? 2.5 hours, basically. I don't think I'm going to render this. And so the reason it's making that quite noisy thing is because of the noise I added. So I'm going to get rid of that noise. Let's scale the noise right down. So I'm going to say let's make an amplitude of about 4, 5, and then I'm going to normalize it out a little bit. Normalize it again. So now it should all just be red. And this time I'm going to say turbulent noise from alligator 1D. I'm going to multiply that. What that's going to do is it's just going to multiply the amplitude of it from 0 to 1. And I can just change this to be a bit higher frequency. It's just a small trick I like to do. Not really a trick per se, but it's something. And I'm not seeing any changes. So it's very subtle. Honestly, you can still use the pop force. It's just another way of having a bit of a finer control over what you're doing. Okay, so I do like that currently. I'm going to add in the pop force as well, and I would probably add in a third one later on. But for now, I do like that. I'm going to cache out these points. So create points from this. Stop. RBD fact object 1. Cool. Let's give me all those. I want to make sure I have got the pH as well, so that I can adjust it how I want it to. And I'm going to cache this out. So let's go to here. I'm going to say this is going to be initial cache. And I'm going to say initial cache here. Very boring name, I know, but it's just going to help identify what's what later on. Because as I said, I'm going to do two versions in a sense, where I have a secondary fracture going on. Just googling some stuff so that I remember what I am talking about. Um, so I did a video a while ago doing a more advanced destruction technique, but can't find it, which is very disturbing. Hmm. Channel debugging, manage videos, debugging. No, let's go to live videos, ship effects, debugging. One of my videos is blocked. Oh, it's the video I want too. So let's see. We've got some code up here. Don't think it's the right one, but let's have a try. So I want to go down and make an attribute wrangle, and this is going to be a bit advanced because I'm not quite too sure if it's even going to work. So I'm just going to unpack it. So I want to say int points. So I'm going to find the same point, the same name. So I'm going to say find attribute val one point name, name, and I forgot the one. And then I want to get some intrinsics. So if we go into my initial cache, we go to my geometry spreadsheet, and let's go to the primitives. Now there's something up here called intrinsics, which are not even here. Why are they not even here? Here. That is annoying. So there should be some prim intrinsics here, but I don't think we're going to find them. So I was even struggling with this one too, with the video I'm looking at. A little weird why some of these are gone. Okay, that's that name. Then I want to get a matrix 3. Called M3. I'm going to say prim intrinsic. So I'm going to try and find the prim intrinsics. Let's say 1 transform point. I'm going to say matrix M4 because the prim intrinsic of the packed one point. Set prim intrinsic. So I'm going to set my own prim intrinsic. So I'm going to say 0 transform current point number current matrix. Set it. Then we say this times the M4. Yep, that was what was happening last time too. So let's turn off this initial cache. Let's see if there's something we're doing here. Let's try and fetch geometry. Fetch pack geometry. Still doesn't like it. Why doesn't it like it? Why doesn't it like it? Let's take a look at the intrinsics. Packed instance, packed instant, packed full. Is it packed full transform? That I want packed full transform, packed full transform. Do I need to not pack it? Okay, it can't be packed. That's fair. Okay, so the reason I'm doing it this way instead of doing like a transform pieces is because I'm going to fracture these again. So let's start by fracturing them. Okay, let's go to assemble. Let's go to a for each name primitive, and I'm going to refracture them. So, however, I want to keep a particular thing, which is the name. Also going to need to unpack these. Need to unpack these. Go on, unpack. You're not unpacking, and then unpacking to the name. There is name. Valid attribute of name. Are you serious? There we go. Okay, now we're going to get a proper one here. So what this is doing is it's taking the intrinsic of the transform here, which is this transform. Where is it? Right here. And we're basically copying it into a matrix. A matrix is, so this is a matrix. This is a matrix 3, so it's different to matrix 4, but let's go back to paint. A matrix, are you there? Is, if you can imagine, it's like a vector, but a bit more complex. So let's say this is the first one, so we're going to say 0, we're going to say 1, 2, and a matrix, so if it's just a normal matrix, we tend to have 4 values, so 1, 2, 3, and then 4, like so. However, with the matrix, we also expand it lengthwise. So we then say, okay, 4, why did my size of my thing go down? So we say 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. So 16 values all up here. So that's what a matrix looks like. And they're very complicated. They're kind of hard to get your head around. But what we use them for in 3D is to scale, is to rotate, is to transform. They are the basic building blocks of how we do everything in 3D. A matrix 3 is, instead of 1, 2, 3, 4, we just say 1, 2, 3, which means that the matrix is going to be this big. So that's a matrix 3. And that's just what these are. We're just getting the transforms of them all. We are setting the transform to be the same transform as this one here. And then we're multiplying the packed version of that transform to our current position. And this way, we can have stuff work. Okay, so the reason it's not working right now is because I've unpacked it. That's fine. I'm also going to just color all these. I'm going to say color primitive random from attribute. I'm going to say the give me the name. The attribute is name. So now we can see we've got all these points. I want to give each one of these about 2 to 3 fractors itself. So what I'm going to do is I'm going to say scatter. And because these pieces are so small, it doesn't really matter. I don't really need to make a VDB. So I'm going to say about, let's give it a, no, let's not give it a density scale. I'm going to turn off the relax iterations. I'm going to say about 5. About 4. Actually, I will turn off the relax. Let's say about 5. Actually, I might even just use the density attribute here, so that the bigger that is, the greater the density it's going to have. So now I'm going to do Voronoi fracture. And this is going to take a long time to do, by the way. So, what have I done here? Come on, get rid of you. That's annoying. Let's go back to scene view. Okay. And we're going back to my light view as well. If I turn this off, it's going to take a little while to do. Let's try and speed it up. So I'm going to go back to single pass. I'm going to say multi-thread. I'm going to lay down something called a compile block. And I'm hoping that nothing in here is non-compilable. So what this should do is it should now just multi-thread the entire operation. So it goes a bit faster. And we can see it's going a bit faster now too. Cool. So now, if we color that, we've got hundreds of these little points. But you can see that a lot of these are the same color. And the reason for that is that they're not really the right name. So what we need to do is we need to set the names ourselves. If we take a look here, we go down to here, we're going to find several hundred of these are going to have the same pieces. And it's going to be a bit slow right now because I just selected, I have a selection on one of these, and instead of compiling it, it's actually just going to do this, which is a little annoying. So what I'm going to do is I'm going to hit stop again, make sure that's going to the right one. I'm going to say max iterations of about 500. And we're going to see that a lot of these have the same name. We don't want that. We want to set our own name. Okay. So what I'm going to do, how I'm going to do that is I want to first of all get the current iteration of what we're doing. So the current number of the primitive that we're running on. So the way I can do that is I can go to my for each begin here and I can say create meta import node. This is going to give us these 4 different metadata, or just data, which is the iteration, the number of iterations there are, the value and the I value. I don't really know the difference between the value and I value and the number of iterations. they generally tend to be the same. I think that will change if we use a different type of merging here. But for now, what we're going to do is we're going to go out to here. We're going to see we have this name, this piece. It's going to give us a piece prefix. It's kind of what we want, but it's not really. So what I'm going to do is I'm going to say put down an attribute wrangle, and I'm going to set it to the primitives. I'm going to say s at name equals nothing. So now the name is just been deleted, basically. I'm going to say I want it to be let's say I want to add it to the current name that it already is at. So how I'm going to do that is I want to figure out what my name is current first. And all I need to do for that is I just need to plug in a second input in here. So obviously that can just go there. That can just go there. Yeah, a bit disorganized, I know. I'm sorry. I just mucked that up. I just mucked that up completely. Alright, so I did too. Come on. Back it up, 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 back it up. I'm just going to bring this out here then instead. So what I want to do is I want to get the current name of this piece. And this piece, I can just get the first value. It's always going to be the same. What I want. So I'm going to say s at name equals. And what I'm going to do is I'm going to say string in name is going to be prim. It's going to be the same as point. It's just going to be prim. I'm going to say 1. I'm going to say the name is which is the attribute I want to get, and it's just 0. So that's going to give me the name. If I just say this is in name, then we're going to see that it's actually the current piece that we're working on. I want to add this to the current piece we've already got. So how I'm going to do that is, so it's piece 49499. What I'm going to do is I can say plus another value. So I got that. This is not a good way of doing it. It's not a good way of adding strings together. So what we tend to do is we do something called a format. The way we do a format is we put the string first, then we put in the values that is going to be overriding this string. And how we do this, we say a function called sprintf. Sprintf is going to format the string for us. And the way we do it is we can say, I can put down an underscore here, and I'm also going to say s at name for the current name that's already there. So I want to say this part over here is going to be in name, and after this underscore I want it to be the current name of what this Voronoi fracture has given us. So what I'm going to do is I'm going to say a percentage sign s, which is going to give us this first one, which is the percentage sign is saying grab, and then the s is going to say grab a string. I can say I can say d. So they've got decimal integer. It tends to be good if you just say $s for when you're working with strings. And then I'm going to say $s again. And what that $s again is because there's already been one $s, it's going to grab the first input. If there's a second $s, it's going to try and find to see if there's a second input. If not, it's going to grab the first one again. Normally. Currently it's not, which is kind of weird. But it normally gets a second input. So now we've got proper names being set up here. I also want to make sure that my name stays, that the name of the main piece that we're cutting up again stays with me. So I'm going to say s at old name equals in name. So now we've got the old name and we've got a new name. Okay, what's this error that's giving us? Nothing to tetrahedralize. So this is a common thing that happens with this Voronoi fracture. We don't need to worry about it. But now, if I'm going to set max iterations off, okay, let it compile, we should see that the majority of these have now got a unique name. And we should now have, if we get past all these errors, we should now have 338,000 unique names. And over here, we used to have 8,000 unique names. So now let's try and add this together properly. So I'm going to pack it again. I'm going to say assemble. Yeah, I'm going to say assemble. So now it's going to say go to here. I'm going to turn off the name attribute. I'm going to say create packed attribute, and we've got the name working as we want it to. We might need it to transfer the old name as well. We don't want that. We want it to just So we want this name, we want the old name to stay along with it. So actually, I'm just going to swap them around. So inside here, I'm going to say new name equals this, and then the old name is just going to be the same one as it was. So now I just swap the values. Hopefully people still watching. So now we're getting this working, and if I color it, we can see that the fractures, if I take in, instead of this name, and if I unpack it now, we're getting a new name. And if I say, yep, how about you use the new name instead, we're now getting a lot of different variations on those ones as well. Cool. So what I want to do now is, because I don't need that new name, I don't need that old name anymore. What I do need though is I still need to have the age. The way we can do that is I can say int pt, it's finding the attribute value here. I want to say f at p age, which is the positional age which I made. So I'm going to say 0.1 p age point. So hopefully that I'm going to tell the intrinsics, hide all intrinsics, going to go back to the point. The p age is now working. Cool. So I've just transferred the p age over. I'm also going to now save this out again. Unfortunately, saving out packed geometry is a lot more computationally expensive. Okay. So now I'm going to unpack it, and I want to switch the names around basically. So I want to say attributes. So there's a different way of doing it. I think it's attribute. Is it attribute cast? Nope. Attribute rename. And I want to I want to attribute delete um, the name, because we've already got the new name. So I would say new name to name. Hopefully that's right. So what's wrong with it? New name not found. Oh, that's point, right? Okay. Move to name. There we go. And now we just have name. Okay. New name to name. Name. Transform pieces. Okay. Now what we want to do is we've got this working nicely. I'm also going to go down to here, go to my file cache, let that fracture out again. Go to U, and I'm going to say head fracture high for the higher res head fracture, basically. Make sure this is being loaded. That's being loaded. It's still a bit slow, but that's fine. So I'm just going to head back all the way. Okay. Now what I want to do is I want to make this into its own little point, really. So what I'm going to do is before it even animates out, I'm going to put down a time shift, and I'm just going to freeze the frames there. And then I'm going to say connect adjacent pieces, and it wants to connect between each name, honestly. So if I say adjacent pieces from each point, it's just going to do something like this, which is kind of a web. But I just want to connect between each point pieces, sort of thing. So what I can do here is I'm going to put in another for each. I'm going to say for each new name, like so. Plug this in, and it's going to go through each name. I'm just going to say let's do 10 pieces overall, please. Not even that. Let's just do 7 pieces because this is this whole piece. I want to convert this into like a connect adjacent pieces here. It's not going to work though. So what I need to do is, first of all, I believe I might need to assemble it. So if I assemble it, turn off this name, and I say create pack geometry, and I say connect adjacent pieces. Say adjacent pieces from name. Yeah, it doesn't like it. Okay, but here under this place here, what I can do is if I have an assemble node, I can get all the points. Remember? So I can get, if I explode this out, I can get, if I turn this down too, hang on, no, I don't want, I want to, before I get rid of all this, I want to pack properly. So I'm going to say delete name, no thank you, I just want to say, yeah, just do the first name please. And then I'm going to say assemble. If I now, so now it's got this here, I'm then going to say delete this name. So, and now we're going to have 7 unique names here. And I want to connect these here. So, say connect adjacent pieces. But yeah, I can start this. connect those adjacent pieces, I'm going to say from 7 points here, and that's how we can do it. Oops, wrong one. So now, if I now go do another compile node, because I don't want this taking forever. Let's say multi-thread when compiled, and then max iterations, turn that off. We're now going to get this nice looking piece here, which is going to be connecting all the adjacent points, I hope. Let's just increase the radius so that nothing gets left behind. Maybe we can even increase the max connections to about 2. No, one will do. One will do. And so this way, what we can do is we can honestly, we really don't need to. We probably don't need to do this, but this might be a nice effect to have. It might turn out nicely. So now each one has a proper unique name. How many unique names are there? There's 31869. How many is there here? So it'll be a different. It should be a different number. I hit the wrong thing again. I'm going to disable you, re-enable you, let it compile. There we go. So now 3726. So it might not work because it's not connecting every single piece, which is a little disturbing. But let's keep going. Let's bring in the dot network here. Let's bring in a assemble. Plug this in. I'm going to say create pack geometry and keep the name. I'm also going to delete the name here, like this. So now they all have the same name properly. I'm going to put down 2 nulls because I'm not going to bother connecting them. So say out secondary cracked, and then out secondary constraints. Color these nice and green. And I'm going to dive inside. I'm going to say packed object. So I hope that's the right one. Let's take a look. Oop. I was right the first time. So fracture, so rigid body solver. There's pieces. Let's go to a constraint network. So I'm going to turn off the display. I'm going to say constraint network. Is it constraint network? Or, yeah, constraint network. The SOP is going to be out secondary constraints, and I just want it to be glue. I really don't care what type it is. I'm going to say glue constraint relationship. I'm not going to find anything because we need to set some variables. So we can do that by going to attribute wrangle. We're going to have a point name. That's what we want. We want primitives. So we want some primitive things. We're going to say s at constraint type equals all. Hope that's how you spell it. S at constraint name equals glue. Because I am lazy. Now I'm just going to say glue. Now we can see all our constraints have now been added. What I'm then going to do is turn off the constraints, because if we show that guide geometry, it slows the simulation down by about 4 times. So it's not something we want. So yes. So we want to make sure that it is actually animated. So we want to say create animated static objects. then what I want to do is, while it's emitting outwards, so we want to scale it by the name. So let's make another, just bring these up, keep this down here. I'm going to push it up here. I'm going to make a new one down here, and I'm going to be running the active attribute on here. So I'm going to first of all put down a color so that we can see what we're doing. I'm going to make a point drop here, and I'm going to bind import the oops bind bind the pH, I think it was called. Where is my age? pH. Once we unpacked it, it kind of disappeared. Let's go pH again. Just make sure that it's copying that over. pH. Then when we bring that back in, we're deleting it, so we want to transform it back up. So let's take a quick look. pH. Yeah, it looks like it's working. Okay. Let's just connect it to the color for now, and let's see what we've got. So let's go color. Actually, no, we want to promote that from a primitive, from a point to a primitive. So primitive to point, color. Now, yep, we can see it's working, and I want to basically turn that attribute on based on how old it's been alive. So I'm going to do a switch statement here, and you'll see why in a second. I'm going to put down a constant. I'm going to put down two constants. So I'm going to say vector. It's going to be white, and then this one is going to just be red. And so it's just going to switch between the 1 and 2. And what I want to do is I want to say once it gets past a certain age, switch. So compare between pH here, and not 0, but I want it to be, it is greater than, let's say greater than, let's say about 2. Let's say about 3, 4. Let's say about 3. 3.2 sort of thing. Once it's greater than 3.2, then we want to switch it on. So what I'm going to do is, once this is on, I want to, instead of change it from that, I want to change these to a integer, both of them. So once it is on, so this is going to be, what I'm going to do here is I'm going to say two attributes. I'm going to say bind export two attributes. The first one's going to be active. The second one is going to be animated. I'm going to make sure these are integers. And what I'm going to do is, so if it is greater, then I'm going to turn on the active. But if it is less than, so I'm going to switch it around, then it is animated. Okay, cool. So now I'm actually going to put that above here, because it might actually work now that I've set the animated and that on. So let's go to here. I'm going to say create animated static objects. I'm going to say overwrite both of these. I'm then going to say gravity. And I'm hoping, I'm crossing my fingers, that this will actually work. Can't see anything because I don't have my display on. I'm going to turn off the color. And I'm just going to go to a certain frame, and I'm hoping it's going to work. And nothing happened. Don't you just love it when that happens? Okay, animated, static objects. So let's take a look at that. So primary point, right from attributes, set animated. That's animated, yes. Why isn't it actually taking the animated from it? I don't think it has to be promoted, does it? Active, animated. Does it have to be a float? Very unusual why the active thing doesn't work. Also, I wish this went faster. Yeah, we've devolved into this area where I'm trying to figure out why something's not working. So I'm probably going to do the method I did last time, where I do a import geometry thing. Yep, okay. Looks like I'm going to have to do that then. Before we do that though, let's try and promote these. Better yet, let's put it before. And let's just see what the color says. Compare the pH. pH is it's a little unusual. Nope, there we go. That's working. So let's try and actually just put it before we assemble it. That shouldn't make a difference. But knowing Houdini and the fact that it likes to mess with me at times, I'm trying to, especially when I'm trying to do something like this, is I'm going to say create animated static objects. Brilliant. I don't, something's happening there. Let's keep going a few more frames. Nope. Still doesn't want to work. I don't think it's because of the constraints, but I'm going to try anyway. Because, you know, I'm going to try anything at this point. Frustration is paramount. Okay, I'm gonna hard code it. Come on, come on. So create animated static objects. So ideally, what should now happen is even if I don't have this, I use this instead. Is it should ideally at least animate. Oh, why does it never work? Those pieces should be moving, shouldn't they? Take a look. Really, just really. But they should still be moving. Let's just take this completely out of the picture then. I'm hoping it's not a deforming object, because it could actually just be a deforming object instead. Ideally, also, come on, start. I'm going to just time shift it towards when it actually starts. So a little bit less. So I'm going to say $FF2 because that's per frame. So I'm just going to say 15. So that's basically what we'll do it then. Okay. Okay, I'm just going to skip forward 10 frames basically. Hang on. Did I click on the wrong thing? I did too. This one. Okay, so it looks like it could actually just have been deforming objects instead of that. So let's go back. Turn that back off. So it's not animated anymore, it's deforming. So let's grab you. Instead of animated, let's say deform. Here's deform. So override attributes, revert to defaults. Deforming is what I want. So I'm saying deforming. Yeah, so I'm actually going to keep animated to 0. So animated is going to be to 0. So deforming and then animated is going to be a constant value of 0. I'm just going to keep it to an integer value. I'm going to say create overwrite this. Cool. Now ideally when it is starting to act, when it activates, it should just fall to pieces. see the pieces are going out together, and then they just fall into pieces as well. So if we want to, we can add, say, instead of the gravity, and instead of this too as well, because we might need to have like a push apart thing. So what we can do for the push apart is we'll need to have like a velocity in a sense. So let us take a look at how we would go about doing that. What we would do is under here, actually. So let's do a for each main primitive, and let's do this before the deletion of that name. I'm just going to say max iterations of like maybe yeah, 15, whatever. Okay, and what I want to do is I want to say now for each. I'm now going to say for each name primitive again. Inside this one, I'm going to do new name. So new name. So each time I do that, I'm going to say yep, do one for new name, sort of thing. Hoping this will work. Except one of these pieces doesn't seem to be working, does it? Let's go back to that one here. No, it does seem to be working. Okay, we want to basically explode these. So I'm going to say for each of these, I want to get the centroid. So the way we can do that is we can just say attribute wrangle, and we can only do it in vex. We can't do it in bobs, unfortunately. So in attribute wrangle, I want to get the current center of this, and I want to get the current center of this here. So I'm also going to do a compile block, because I know that this is going to take a long time. It's not going to like it, so I'm going to say multi-thread. It doesn't like a block begin fetch input may be needed. So let's say multi-thread again. So we probably can compile this one as well. This one will want to be here. No, this one wants to be here. This one wants to go to 5. This one wants to go to number 6. Why doesn't it like it? Okay, all right, getting rid of it. So I'm not going. Oops, not going to use the compile blocks here. Not this time, so it's going to be a bit slow. Well, I want. Oh, hang on. That would be why. So I'm going to show why I was doing that. So I'm going to say compile block. Put down a new compile block, so it's all complete. I'm going to plug this one in. So I'm going to plug this one in here, and this one in here, and it's going to complain. The reason it's going to complain is because that each input needs to have its own block. And the way we do that is we say create metadata node again, and this one's just going to say fetch input, and this one's going to go through here, so, and I can even put it like that if I need to, but what we need to do now is we need to say compile block in here, and then, so now that's going to work. Don't see it working. There it is. And now what I want to do is I want to say get the current. This is just going to get the fetch input of that. So I can say get the center of that point. And the way I can do this is, so let's go into, let's just say points for now. And I'm going to say centroid get vbox center of this because it gets the center of the bounding box of the geometry. We don't really want that. So what we're going to do is we're going to go over a detail. We want to get all the points, we want to average them out. And the way we do this, we say for int I equals 0, I is less than the n points of the first input, then I plus plus. Then what we can do is we can say, okay, well, let's add all the positions together. So we can say vector equals 0 for starters, because I did explain this as well beforehand, I believe, equals to the point 0 position AI, like so. What have I done wrong? Yep, I don't have a semicolon there. And then afterwards, I want to say pos divided by endpoints 0 minus 1. So that's going to give us the center position of the box there, which is what we want. Now what we want to do is we want to get the center position of the other one as well. So handy trick we can do here is we can make something called a function. I'm going to press Alt E. That was Alt E, I should say, and it's just going to make this box a little bigger. And the way we can make a function is we start out by saying the return type. So the return type is going to be a vector. We're going to call it get center. I spell it with the Australian English. We can have variables we want in there, and then we got this, and that should be our function. And what we do here is we will just copy paste all this. So, and I want to say the integer of the, because I want to get the current what we're going to be going over. So is it going to be input 1 or input 2? I'm going to say input number here. Let's hit apply. And inside here, I'm going to say input number, and instead of 0, I'm going to put that there. And now we need to give it a return type. So I'm going to say return pos. That is going to give us the return of every single point. So that's what a function is inside of Vex. I'm just going to hit accept. And now to call it, I can say vector pos equals, and this pos is going to be different from this pos because this is going to be inside this one. This one's going to be outside this one. So I'm going to say vector pos equals get center. Actually, I'm going to say center here, center A, and I'm going to say 0 because I want to get the first input. What's wrong with this? Why doesn't it like it? Nope, that's good. And get center B for the second input. Now that we've got that, what I want to do is, honestly, I'm actually just probably going to blast it. I'm going to just say remove point. So that way we have nothing in there. That this is just a visualizing thing for me. So what I've done is I said go over each point and just remove it so that it's not there anymore. And now I'm going to say add point, center A. I need to, of course, say which input it's going over, which is the 0th input. And then add point B. And so ideally, what that should give us is some points. It is not. Let me think about why. All right. That might be why. Nope, that wasn't it. So let's do that then. And instead of, so we are getting some points, but they're not in the center. Why are they not in the center? now in the center. Hopefully. Don't know why I'm removing the points to that. But anyway, instead of this, I'm then going to say okay, this is a bit too complicated. So I'm just going to cheat again, as usual. I'm going to say assemble. Say create packed image geometry here. I don't care about the name. I'm going to keep the name. I am going to then just say add a point over the spare input. Add the point there. I'm going to say point -1, 0 for variable input, p for the position, 0 for the x, 1 for the y, and 2 for the z. So now that has made a point. It's kind of hard to see, so let's go and go to dark view. There's our points. It's perfectly there, so that was a lot easier, honestly. Once we've got that point there, what we want to do is we want to transfer that. So let's transfer the name. So now these has the name. These have the name, I should say. Although honestly, we shouldn't need to worry about that, because each one should have their own unique name. So I'm now going to say attribute wrangle. Then going to say okay, vector pos. Now this is going to be the vector of the position that we want. So we're going to say point 1. So this is the, I'm going to say this is the center of me, position of 0. So I'm getting this position now, and I now want to get the position. Oops! I now want to get the position of. Honestly, what I could do here instead of just the assemble, I just got that. And now I want to get the position of the central position of this one. So we're going to need to do the same thing. So another assemble. This one's going to be assemble 6. It's going to go into that one, which is fine. So now that's going to give me a point in the middle of there. And then I can say vector away pos. It's going to be point 2 for the third input there. So 0, 1, 2. Position and 0 because it's only 1 point. And then I want to say v at v equals position, take away the away position. So now, if we take a look at our velocity, ideally, we should now have, okay, so it's pointing, should be pointing inward somewhere. Come on. Come on. Let's try away. Pause. Let's pause. Because I don't want all of that to be pushing out against itself. Come on, is that, what's the velocity doing? So it's tiny. So I'm going to normalize this. Normalize that. Still, okay. There we go. Now we can see it. Now that we're going to be pushing away from the center of itself. And that may be something you want. I don't generally know. But that's something I'd like to have. And I'm probably just going to keep that scale down, honestly. Maybe scale it up just a bit. Actually, no, I'll keep the scaling for later. So now if I go to the power block, it's fine. If I go to U, if I go max iterations, it's going to take forever. So let's hit stop. Let's hit max iterations again. And let's see if we can compile this one. you. Make sure multi-thread is on. Make sure multi-thread is on. Go. Go. Yep. There we go. Now it's multi-threading away. So it's nice and fast. Okay. So now we have given all these a velocity. But not quite. So we need to just transfer the velocity over to wherever this is. So we want to probably turn it off. Come on. Come on. So what I want to do is I want to time shift this as well. So this one is going to go to here instead. Because I don't want this to be animated. I want to animate it after the fact. And I want to make sure that doing it correctly. So I am then going to go down to here. Scroll across like that. Before this as well. So I'm going to keep these names. I'm going to make sure I can transfer these attributes across. So attribute wrangle. No, actually no. Like so. Probably should sublet this. I'm not going to, so that we can just see what's going on. I'm going to say find attribute val again. So that number we have, so point equals find attribute val. The one. I think what was the next attribute we needed? So we needed geometry, the string attribute class, which is point, the name, which is name, current name that we're looking for. There we go. Now I want to say, okay, v at v equals the point 1 v of the point that we're getting. And now, if we take a look, we're not going to find it. So v at v. Let's normalize it. Normalize v at v. Did it spell it right? Is the velocity coming over? Name. Three, 1, 8, 6, 7. All right, so I need to also do that down here. So that we're getting the same names. Okay. Okay. So let's times them by a lot. Hopefully we can see it. Nope. Why can't we see it now? 31869 by 31869. Okay, so they should be on the points. So let's go past the assemble. So now that we are on the points, let's go past the assemble as well. And I'm then going to say instead of age, I want to put v. So now we are getting a velocity. Okay, so instead of doing it this way, what I'm going to do is after this, I'm going to go down to you. I'm going to do attribute promote. I'm going to say, instead of primitive point, I'm going to say name. I don't want to say name, change new name, delete original, no. I'm going to say match name. So now I can just say match the name instead. So now it's on the points, and then I can just promote this to a name. Okay. Match name, and wait, no, that should be match name there, and this one should be name here. Okay, there we go. And that's too harsh. But now we are getting the velocities pointing outwards. Cool. So now what I can do is I can throw that into there. Let's assemble. Stop this. And what I'm going to do is, because I'm also going to do an attribute delete name. The attribute delete, because I don't need that match name anymore. It's always a good idea to delete what you don't need. Dive back inside here. Delete. Stop that. And what's going to happen is, when I turn the solver on, when I actually start simulating, it's going, because I've got a static deforming object, it's just going to wipe out the velocity straight away. So I need to have a trigger that says, hey, is active on? If the active is, if the geometry is now on, then add this to the velocity. Otherwise, the velocity is just going to be nothing. As you can see, it's not really splitting apart properly. So we're going to have to do another subsolver. And what that's going to entail us to do is, we're going to dive inside, and we're going to create a attribute. We're going to create an attribute. So I'm going to create an attribute wrangle here, and inside this one, I'm going to say, hey, if I at active is equal to 1, it's greater than or equal to 1. If it is greater than or equal to 1, then I want to add to a variant. So I'm going to say f at, so I'm actually going to say I at count. So it's a count is going to be plus equals 1. Okay, Now then, I'm going to, after this, I'm going to say if I count is greater than, let's say 1, then don't do anything. However, if it is, I'm going to say if I is equal to 1 exactly, so it's only going to happen on one frame, then get the velocity, add to the velocity. So I'm going to say v at v plus equals, and I want to add to the velocity. So I'm going to say int point, it's going to be defined attribute value again. It's going to be 1, say, so point, I believe. So these have like a v velocity here, and I want to add to, so these are packed fragments, I want to add to the velocity. So if I take a look up here, we don't have a velocity here anymore because the assembler has killed it, so I'm just going to say, yep, add the velocity. Let's go back into the dot network here. I'm going to say point v, and then, actually no, I'm going to say name s at name. So now I'm going to get a point. I'm going to say point 1 velocity by the point. So now I need to do an object merge. Go into here, and I need to take that secondary fracture here because that's where I'm getting the velocity from. Okay. So that means it's only going to be active for like 2 frames. Oh, not even. It's only going to add to it 1 frame by 1 frame. So what should hopefully happen here is to just split apart when it hits that threshold of 1. When it's active, it will split apart. So as you know, it's deforming up until that point, but after that point, it's just going to should split apart properly, and it might do it with a bit of force. Split apart. So let's increase that by a frame. So let's say it's greater than, so it's greater than 0, and the I at count is less than, let's say 2. Let's say 3. So it's going to be active for 2 frames. Point attributes, point attribute name as well. Yep. Okay. Hopefully that will work. I'm also going to scale it up. So let's say v at v times equals, let's say 20. So that's going to really scale it up quite a bit. What don't you like? So I'm going to turn off that solvent creation frame because that's annoying me. Okay, there we go. I can see it's filling apart quite aggressively now. Not what we want at all. So I'm gonna go back. I'm just gonna say maybe 1.5 sort of thing. And by this point, I would make these fractures absolutely tiny. So I'm gonna do that because I don't really have much going on in my life right now. I'm gonna see the scatter. Let's take a look at the scatter. Scatter's giving me like 2. Let's say 200. Say 300. Let's say 200 instead. I don't want to kill my computer. See how many there are. I don't actually know. If we unpack it, we have 118. Cool. That's a little excessive. But what I'm going to do is I'm going to copy that. Yeah, ideally should be fine. Yes, it is late for me. It's oh well, not technically too late. It's like one. It's 12:30, 12:40. So I probably don't need to actually fracture it out so much. So here, what we would normally do is after the act. I deleted the active, didn't I? Okay. So I did need the active. Or did I? I didn't. Okay. So here we can add another point. So what was the original point? False, not false. Let's grab that again. This time inside this block network. So I'm going to say this. So I'm going to give this one, but I'm going to scale it down a little bit. So 0.5. Yep. And then I'm going to do a merge. So we didn't really need to do the constraints. The constraint that would be good if you were doing like a if it was hitting stuff. Doesn't really need to be hitting stuff right now though. So pop force. Actually, I'm just going to copy and paste the pop force there. And inside here, I'm going to put the swirl size. I think if it's bigger. Let me take a look. Swirl size. Can't remember if it's bigger. So no, let's say 8. quick way of figuring this out. Let's make a grid. Come on. Where's that grid? Just put down the grid. Huh? Grid. There we go. Let's scatter some points. Let's make a pop network. Let's increase the amount of points. Let's just say birth for one frame. Maybe two. And let's add a pop force. Let's put the amplitude up. Okay. Let's bring the swell scale up. So the higher the one, the larger the thing. So I want it to be a bit smaller then, to give a bit more fine details. So go to you. Don't want that one. Come on. I want this to be about 1. This one to be about 9. This one to be about 2, so it's a bit less. And the roughness to be about 7. This to be about 0.9. Pulse length to be about 1.3. 1.4. Okay. So we activate it all. Let's go. So it's probably going to take a lot longer to do now because of the amount of points I've now got there. So my CPU is fine. I'll let it cache out a little bit and we'll see how it goes. And then I'll probably call it a night. Okay. So the ampli so this might be stretching it a bit too much, and the pop force might be a bit too harsh. So I'm going to get rid of that. And I'm going to scale this down to be about 0.5 basically. And I'm also going to make sure that it's the same. It is the same swirl size, but I just want to have it the same. So 5. I'm going to set it to about 4.9, but I'm going to have a higher turbulence. Same pulse length. I'm going to have this almost the same attenuation. I'm going to keep it like that for now and I think that would probably do it. So that's my way of doing it. Probably it's not. This might not be the best way. So I do know that there is a CG circuit about disintegration. Um, the first one goes over. It doesn't go over this DOP network part here or the techniques that I've shown, but it goes over how to do it. A lot of it in soft land, but it uses like it doesn't scale down primitives. It doesn't scale down like a packed geo. It scales down the primitives themselves. The second one is a bit better, but it's using impacts to do so, which I think is pretty cool. It might help you there, but a lot of this, the majority of it is what's going to be in here. What I've shown here, how to do something like this. For an example, like what how Peter Parker was disintegrating away is, you know how I had the volume velocity being pulling it away. You could have like sections of that, like sections of density, and make it in temperature. Simulate it going like to the side or something like that, so that it's pushed like it's a like basically little splotches like around here or up here or up here sort of thing, where the fire would be moving away. And you can vect the points with that as well. So that might be something you might want to try. Mm, not sure I quite like that, but that's uh to continue this on, it'd be just been me tweaking it a lot more with different values and so on, and that's when we get to the very slow, boring stage of just adjusting all the small details and such. So, but that's the techniques that I would use. Not to mention, once you've done that, so dot network, not dot network, transform pieces. You've also got the option to scale them down with the technique that I showed before. Which was, come on, stop it. Which was this one, which was the the applied age. Then we'd scale it down. So I'll share the file publicly, well, on Rebelway and the places that I shared this file. Hopefully, I'll call this primary. Hopefully that helped in some way. But yeah, it got rather slow towards the end because the setup was done. It was just a lot of tweaking and so on and stuff like that. I don't know why my computer's so slow. I will need to investigate as to why that is. If anybody was watching, maybe they could tell me. I think it's because of my development work, though. You tend to install a lot of things into the registry, and that can bloat Windows up quite badly. So I'm going to try and set up hot swapping so I don't have to. So when I do development work, I just do it on one drive completely, and don't have to worry about messing up this one. But yes, I shall share this, and hopefully that helped.